नमस्कार, गुड इवनिंग। दिस इज जसूरा सिंह स्पीकिंग फ्रॉम भारत इंडिया। मैं भारत इंडिया से जसूरा सिंह बोल रहा हूँ। आज मैंने डिफरेंट टॉपिक चुना है। आई सेलेक्टेड अ डिफरेंट टॉपिक एंड दैट टॉपिक इज एक्सेल शीट वर्कशीट MS एक्सेल शीट माइक्रोसॉफ्ट एक्सेल शीट और प्रीवियस लोटस 123 लोटस 123 one and same thing. Lotus 123 is same as previous one, so you must know about that. Lotus 123 and mathematical formula. This is a very important point that I am going to discuss with you because this is useful in mathematical terms. You want to do formalization, you can use MS Excel sheets, and that is Lotus 123, or you can say MS Excel. MS Excel. That's called Microsoft Excel. You know it very well. All of you know it very well. But just I'm trying to make it easy for you people because many of you may not be knowing what I'm going to tell. बहुतों को नहीं पता होगा शायद मैं क्या बताने जा रहा हूँ उसके बारे में, फिर भी कोई बात नहीं है, जानना ज़रूरी है। अगर आपको पता है तो अच्छी बात है, नहीं तो कोई बात नहीं है, हम बता रहे हैं आपको। अगर आप समझना चाहते हैं, इट्स ओके फाइन। यू वांट टू अंडरस्टैंड दैट, इट्स ओके फाइन। And it's all this, and I can say that this is, if I give name to this, then I can say, well, it's not time for name, let me go as it is, whatever it is. Then it is book one I'm giving you, probably you can take any name, Lotus 1 2 3 6. Now I'm going to sing is this, that मैं कुछ इस तरह बता रहा हूँ आपको कि आप इसका एब्सोल्यूट यूज़ कर सकें। अगर आपको नहीं मालूम है तो, और मालूम, यू नो दैट्स फाइन। We write countings in this, For example, I write one here, you can write two here, right? Some people say, okay, it's very easy. You can, if you just if you say it's very easy to pull it, yes, you can say it is very easy to pull it. So you can say pull like this. It's very easy. Everybody knows this. 1 to 20 or whatever number you can pull. With pull, series goes on increasing, and that's what That's okay, fine. Everybody knows that. But I'm going to do something else in addition to this one. That is not what I'm saying. I don't pull it. 1 and 2 is okay. Now I say, rather than this, I say plus here, plus 1. I put here. So this is this previous one plus 1. So if I pull it like this, means it's automatically done. You see, here B41, no, previous one, number 1 is blank cell. You can say it's kind of blank cell. I have not formalized this, but this cell are all formalized, and I can go to whatever number, whatever it is. For example, you can pull it or you can do otherwise. It's one and same thing. You see, you can look like this, or you can do like this, or you can do like this. This is one method. Or if you want to put numbers on this also, let's say serial number, let's say it's what serial number it is. I can say serial number is here. Let us say serial number is this. So now whatever I have here, I say this, for example, serial number 1. So what is other serial number? That's just a point. So I can say other number is 2, right? Or if I say I fill it in immediately, you see 2 comes here. Or if I can give a formula, I can pull it up to whatever number. Let us say one number I pull it, or I can go same way. Serial number I can increase here with this. I can say, okay, this is this plus this, and this is this. So I just put here, and all change means serial number changes. And if I here put 1000 here, 1000 in this blank cell, so this value becomes all that. You see, you got my point. This cell B, this range B column is B5 valued as, I can say a value, I put in value or formula, what I can put formula, right? Let's say a value formula. I don't get what I'm saying, but understand what I'm saying. First of all, I'm going to share with you my Excel knowledge, which is very brief, of course. What I did in this, see, it is, you can say here is value or formula. So I say it's value or formula. Here, value or formula, and it's mathematical formula composition. Composition is how to mathematicalize this. कैसे हम इसको mathematical terms में डालें? That's point. So what I did in beginning, I did what I did one. So one was just I formalize it up to one, and it can go further. Don't wait, go further. Similarly, don't wait here, just double click here, you'll find a serial number. And again you can say, if I say this is 500 rather than that, so this value is 597, serial number 1 is 98, this is serial number. So you can go to now you say, okay, I don't know this, I want to go in negative direction. Let's say I say, okay, 500, I say no, it's minus 500. So minus 500, let us say minus 500, minus 499, minus 499, like this. Here's that all values change, right? And if I say, okay, I want, say, 1000 minus 1500, minus 1500. So this is value, all value changing so quickly. If I say no, I want 350, 153, say, you see all values changing, and serial number remains same. And this is not very difficult. You can copy it further and change values again. Let us consider, let us say now we make it 100, sorry, this is 10, 100, this is 100, 101, 100, 200, 3, like this, right? So you got 197 to serial number 98. This is serial number, you have to keep 0, 1, 2, whatever, and you can pull both, no problem. You can together pull them, you'll find results are coming in same. You put on them, you say put on them, you say like this, you can, and you can, like this. Do you understand what I'm saying? Now say this is formula of this. I say I want square root of this 100. Let us say this value, I say plus 0, this value is 0, this value is 0. Let us just centralize this first. Okay, now this value is 100, same value, because I link to this cell. This is called linking. I link this cell, I want a square root of this. What should I do? Tell me. Square root of this, I mean to say square root under root. I'm saying square root means not its power 2, let us say power 2. I simply do that, nothing very expensive. I simply put it in bracket, this value I put it in bracket, and here I use power sign, and which is this sign. If you can understand this sign, it's power sign. Where's the value 2? This value 2, got it? This value 2, what is that? I put another color here for your differentiation. So this is that value. I just put it in little maybe I don't know you are able to see that or no. So let us see, let us leave it as it is. I'll put in just different color, little different color, so that it's visible to you. So it is the mild color here. I still not visible, no problem, leave it as it is. Now I want to fill the remaining cells. If this cancel, let us see, you see all these cells are filled in automatically, you see, up to here. And you say I want to pull further this one, I want to pull further, say 50 more cells, 50 more rows. Let us see, you can see how values are changing. this and this all are linked like that. And if I want to change here, let us say first it was square power 2, it is power 2. Now I say leave it as it is. I want to make it another one. I want to make another one here. Let's say power 3. Let's say power 3. I want to make power 3 same value from this one. I don't touch it, no need of touching this. I just go there, just put a value here, this one, and in this I put power 3. Power 3, I put my bracket, parenthesis, these are parenthesis, and this is power. This is power. Where is it gone? I can't see it sometimes because of my eye problem. Oh my god, there it is. Oh my god, I can't see this. Let me put my tube light on. First of all, I can't see that. So I think it's here. No, it's something else. So yeah, I got it. So power 3 means here I put this power sign here, and this is power 3. Let's say power 3. This is power 3. Only for this, if you double click this, you'll get power 3 for everyone. You see this value? You can pull it also, no problem. Pull it any number of power. You'll get us immediately, You got up to 280. 280 value, this linked, and this is the result. Now, that's the simplification of formula. Now, I was saying is, let's think of something else also. Let's put this in center so that everything is fine. Okay, fine. Now, power 2, let's say power 4. Power 4. I do same thing, it's plus, and this is here. Again, this is, this parenthesis I put in, parenthesis here, and I put value of that, power and 4. So this is how 4. So I can just, it's centralized, so it's okay. I can just click it again and it'll get this value. You see now scientific value is coming in. Scientific means a positive value of this. When I say up to here, if I just spread it a little, this scientific values also change. You see here all values disappear in E form and you get real values. Now this is not magic. This is something, you can say practical. Power 5, let's say power 5, and let's say power 5, and I'll just make it a little wider. Power 5 is more, so plus 100. Again, I mean the same one, and let's parenthesize it. I can do without parenthesis also, but let's take without parenthesis, no problem. And let us try, let's say power this one, and 5 is giving, no problem. But I just wanted to keep safe because I wanted to expand that formula further. That's why I was putting, we have to expand. So you can say we have reached to same formula again. Again E have come, so I'll remove this E by if it's possible. So it's not getting, it's no problem. This means it's getting, power 5 is here, and these values are coming here straight away. We'll get power 5 here, power of terms. And now I'll try to again expand this further, and you can say we are going further and further. You can take it for any value. You can take it to any value. Got my point? Right? You got any value. So I say higher. You can further, no problem. Further go to any value. You're getting values there in this formalization. So just think of what you've done so far. You can see we have done a gigantic calculation. This was your, you can say this, I put in this one, and that's what I say. I put in times Roman. So this is times Roman, and I get little, so this is here. So this is serial number, view formula, power 2, power 3, power 4, and this is all Lotus Amscon, same thing, the same sheet. So if I just now what I do, I just give it a chance to be just swear in, so we can understand in a better way. So let's say what I'm doing is I'm giving this in this way. Well, this table is ready now. Now why I don't depend on this table. I can reduce this also because it's only 100. So I take it down and put in, and then I can say okay, I want to save space here. So I have saved the space here. No, this is automized. Now why let us say we want something. Let us say this was, for example, this 100. I want power here to power 2. Now I want under root. What to do with that? The question is what to do with that? Under root of this. How? It was square. So we need this under root. If suppose I want to change in this cell itself, I say this parenthesis value of this cell, and here is square root. So I say okay, if I want to say 1/2, right, is square root or no? So what is this? 50. So 50 is this value to power half is 50. This value, got my point, or I will say I repeat it. Okay, see what it was? It was 1 B5 to power. Now what, before going further, I'll also tell one thing. If I say 100, I make it 200. You'll see all will change. If I make it 300, if I make it 250, all will change. if I take 300, all will change. If you say, you can say 5000, all will change. All will change. So let us go back to same value we have started with, so that we should not be confused. Now this is power 2, power 3, power 4, power 5. Let's say again I go there, I put here 100. I want parenthesis again just for better understanding, and parenthesis again, and I say I give under root. Under root means 1 over 2. Is that one, right? Is that one? This way we should work here on Excel. Means it's not simple. Simply you can say that. We know it. We have to. If you understand, it's fine. I'm not saying you will know. But if just for everybody it is. So I say under root. Power half, I can say power 0.5. You can say 0.5. Right, so now I'm talking under root means 0.5. This is what power is. So 0.5, let us say, if I say 0.6, if I say 0.7, if I say 0.8, if I say 0.9, like that. If you say so I will just so this is now we'll use this power for further understanding of this. Let's see how it, and we also first of all make some graphics, I mean the tabulation here for clear understanding, and let's see how we move faster and faster on this, because it's expansion of automatism on your Excel mathematical calculations. So let's do like this. Let's go further, and let's say we table to form first. So now power, this is power 5, 1 over 2. Even if say I say 0.5, no problem, it can be 0.5, so it is 10. I'm saying 0.5. Now let's say this is 0.5, and this is B5 value 0.5. This is 10. Now I say 0.6. So what we do, we see same thing here. We see what is B5. B5 was here. Now here again I say B5 plus B5. This is B5, and B5 itself say power 6, power 0.6, power 0.6. We will use 0.6. This is power. We have to say power symbol first. Power 0.6. So it's a 0.6. Here it was power 0.5. Now we have powers like this. Let us say now if you just go down, you will find that these are all changing. These are changed automatically. Now you will say how many digits are coming in. No problem. This, it doesn't matter. You can reduce these digits from here. 0 plus minus. You see, you can reduce this. It doesn't matter at all. So that's not a problem. If you don't use it just for understanding, you keep them as it is. Now I say power 7, power 8, power 9. Let's say this is here. I'm sorry. This is here. This is here B5. B5. I'm saying B5 here, and this is here parenthesis. This is here parenthesis, and this is power 7. This is power 7. Power 0.7. It is 0.7. This answer. So I can just answer this. All cells, whatever are they have changed. Are you getting my point? If you're getting my point, I'll be happy. If I'm not getting this point, then okay, fine. It's your intellectualism. So I'll give you power 8 as well. Then I'll change them again. Let's say power 8. This is parenthesis. First of all, I'll do parenthesis. Even if without that I can do, no problem. But just for clarity purpose, let me give you parenthesis so that you understand better than it is 0.08, 0.8. You see, and again if I say 0.9 here, this is this is one, and I say, and this is 0.9. It's here. You can see it's say already. I'll put them in central alignment so that it will be clear. And if I just what should I do? I collect them. That's it. So your table is going to be like this. You see that? So it looks funny, but it's practical. I do is let me put this also in some smart form better. So this kind of table you can say now what I should do. Now it was based on 100. Let us say 500 it is. You see all changed. You don't need to calculate everything. You automatically get this page full of well changed, and you can put any damn value. Doesn't matter. You can put here 1000, you can do a 750, you will get answer of that. You will get 2500, you will get answer of that. It is 25,000, let's put in, you get answer of that, 25,000. Now I'm getting this back, and let us say it is 200, let's say it's 10, let's say 10. You'll get this value. And if I change it again, let's say 750, then let's say 500, that's 100 back. Now, this one point. Other point is, say I don't want to use these powers in here. I want to use just formalize them further. If you are not confused, or further later I'll tell you. Let's go in an elementary way better. Though it's not elementary way. Now what I do? There's another question mark here. Is all powers here? I want sum of these and multiplication of these as well. I want sum of these and multiplication of these as well. Means from cell B5 to cell you say F5. I want sum of this and multiplication of this and various divisions. So what I do, let us say I put certain insertion here, I insert here. So you see of the insertion, nothing changes here because whole formula moves and there's a blank column. What should I do? I want sum, let us say sum summation of all this. Summation of all summation. How does sum work? So don't go to this first formula. This is use 8. Add sum, and this here, and simply what do you do? Tell me. I don't want to do in this case. In this case, I say I go here and power 2, power 3, power 4, power 5. I just leave it and put it. So summation of powers. You can say summation of powers. Summation of powers. Sorry, it is powers. Summation of powers. Got this. In this, if you see some C5, I did not leave that. I because there's a formula. I did not sum it up. Y2 this is the one, right? Summation of powers, and this is all summation goes like this, because whole cells are filled in. So which one is best cell here and control cell, which is original cell? That is this one. Now see, I want to change this to 100 to say, let us say 200. You see unit value here in summation power, and it's changed. All changed there as well. But I'm talking of summation of power, complete change. Now I'm saying okay, leave it as it is. Summation of powers. Now I say summation of powers here as well. Summation of powers here as well. Summation of powers here as well. We want to sum this as well. So what to do? Power of 0, 5 to this one. Let's say same formula. How many cells were there? 1, 2, 3, 4. How many? Here are 5. I think that formula won't work because there are different cells. So let us say sum at rate at this is the Lotus formula I'm using. Remember, I'm not using much Excel formula. It both works there. At sum, because you can use equal also. At sum, and that is power 10 to this one. And I say okay, fine, this is done, right? So I've done what I've done. just use same formula here. I'm to say same formula I used here, and now I'll clip it, and you see this formula has come everywhere, and I like to like this summation of powers. I also tabulate this completely. So this is what we have done here, summation of powers. So what we have done, one answer is here, this is, and one answer is here, summation of powers, and this is here and this is here. Now suppose I want to completely, this is power here and this is power here, I want to subtract these powers, sum these powers, some we have already learned, this is summation. I want to subtract from this value or any power of this value, let us say any power of this value. So what I do, you can say this one, summation of power minus this summation of power minus summation of powers, let us write here minus summation of powers minus summation of powers. Minus summation of powers. So what I do, I push Alt here and you go like this, minus summation of powers. It's actually minus summation of power, this actually here, so I'll take it there from off because this is minus summation of powers. So what I do, let us say plus, this is plus here and minus here, so this is summation of powers. Result is this, got it, minus summation of power it is. I'll just give you italic bit to this so that they'll make a differentiation. Minus summation of powers from both one, summation of power 1, let us give this name 1 and let's give this name 2 just for clarity. So power, we can say summation of powers 1 and 2 from 1, summation of powers 2 from 1, this is summation of powers. Minus summation of, let us say minus result summation of powers, minus result of summation of powers 2 from 1. So this is 2 and this is 1. This is answer, and this is not only for this is for all. It's for all, and this is for all here, and this too I can say it's like this. So you can see the result. Got my point? You can see you getting complete results. If you want to expand that, but you can expand, doesn't matter. Very easy. Just move it up to here, and it's done. It's 5 or 6 here. You can go further. Let us say. You see, where we are reached. You are laughing or no? That's my question is. You are 1160 and that's say, let us say 1160, and you are further going now. And you see, you are going 1195, and that's a little more. So 200 you are close. You are getting my point I'm doing is, it's kind of a formalization of calculation, or you can say application for formula. This is application software. You may say software use doesn't look nice, but let's say application. You can make application here and you can write formula yourself. Why did you choose this formula? So I'm not stopping here, I'll move further. This was minus sign. Now I want to divide this one by this one. Let us say division. Minus, let us say division of power 1 by power 2. Power 1 we are saying and power 2 I'm saying. So let us say division of power by division of power, let us say it's alt here, and this is the 1. So division of power 1 by power 2. This is what we are going to do. So what to do? Division, let us say this is a plus sign, this is a power 1. I want to divide it, division is this, and up to power 2, it's power 2, I want to write this. This is an answer. You can say you got answer here. And this is you see formula G5 divided by M5. So you can reach it to 1200. So you go down to 1200. You are getting this answer here, and you can move down further and further. Every value is there, no unchallengeable value. No one can challenge it, and you can change them by from control cell 100 or whatever value is there. It doesn't matter. So we go about control home. We go back there. Now let us say this is control value. You can say control value of formula. You can write here control value formula. I'll write in full control value formula, because this is very important in every application. Control value formula. This is you can say remote for everything. If you understand this, you can devise any formula. So now what I do, how many calculations we have done? Let's say this formula. I change here, everything shall change. Yes, of course, I forgot that to tell you. I think this is also moving, right? Serial number is also moving. Yeah, serial number is also moving same time. So it doesn't matter. Control formula, you cannot touch other than this. If you interfere somewhere else other than this B5, you then kill this whole formula. So you are only going to fight with this 100. You can put any value in this. You can put, let us say, 100. Let's multiply it by 3. I'll try to multiply it by 3. Plus sign I'm using because without the formula can't come in. Let's say multiply by 3. So you are getting complete values, right? So we can otherwise do. Now I do not use this 3 value here. What I do, I want to change all these values. How to change? I say 100 is control, right? You're getting my point? I think you're getting my point. If you're not getting, it's difficult for understand that. It's very important application. I'm telling you, it's not very important, difficult English as well. So you should get my point. Now what I do further, this is division of that. What I do know, I told you sum, that's a plus. I told you minus. I told you multiplication. Just now I told you multiplication, and also I'll multiply them now as well. Let's multiply. What multiplication? I'll multiply this power 2 to power 5 together. And it will be very big value, doesn't matter. Let's say I'll squeeze this sheet further so that you can see how I'll squeeze this sheet. Now I'll multiply this. Multiplication, power 2 to power 5. Multiplication power 2 to power 5 to power 5 power 5. I'm going to multiply this. Multiplication power 2 to power 5. So this is how I want to multiply this. It's not difficult. Only thinking is difficult. Otherwise, there's no problem. It's very, very easy. I'll do this one. As I multiply other one, that's power 0.5 to power 9 as well. Power 0.5 to power 9 as well. So I'll say that's, I'll multiply as well. That's power 0.5. I'll write 0.5 here. 0.5 to 0.9. 0.9, right? 0.9. I'll do this one. So I'll just make it, this here. Now I'm going to do this one. This is very important point now. Power to power, what formula is there? Actually, this is a product formula. Product. Let us say how. Add product. Automatically it comes in. You can see. Add product this. Don't worry about that. Just go to power 2. Put your click cell here. Go there, and step here, and you get the answer. This answer is coin. The answer coin. This answer. And similarly, if you do that, that is add, product. Add product. Again parenthetical, and you go to power 5 and power 9. Got it. This is the one, right? It's given because it's very, very small. Don't worry. Result is there. Product is H4, L4 or age it's giving. So these two products are there. I'll again click them and you will see all results in there. So you see how much time can you save. Go on browsing this. You will find how result filled in, how where it was zero. It's giving an answer. You see, it's giving big answers, right? And you're saying it was zero in the, let's pull like this and see how it's moving, like you see on monitor of airports how it moves, or on display how it moves. Complete values are moving in, and where it was zero, you see it's moving in. So how many cells you have, how many rows you have, I'm sorry, how many columns you have, result in 1, 2, 3, 4, 5, 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 columns you have calculated just based on one cell, and that cell is B5. I call it free cell. This cell which is showing yellow color, this one I put this bigger font so that you can understand that. You can differentiate that one. I put this here, and I can even put value better. I put this say 12 or 14, so that you can understand this is a different cell, and I can say I can give you different mode here. So this is control cell. This is controlling whole calculation till now. I think you enjoy or you will bored, I don't know, but I think you should enjoy. Let us put something, some in a different form. Let's say this one. No, that's okay, fine. Let it figure on. No, this is multiplication. This is division. I give you. Sorry, this is a division. I think multiplication. Okay, fine. This division was this. Sorry, this was division. Let us say, and this is multiplication. So what we have done? We have done sum. We have done reduction, or you can say minus, and we have done multiplication, and we have done division. What formula we use? That's very important. So what formula is? I'll give a list of that. For example, I give here. Don't be confused with that. I'm giving. I can't give sum, but don't be confused with that. I'm just giving you something like or I'll write on next sheet better so that you are not confused one. Let's go to next sheet, and I'll say how to handle that one. Let's go to next sheet and see what I'm saying. Let us say sum. How to sum or add sum or add. Let's say it's no different. Use add, or you can use equal sign depending upon your choice. Sorry, this is not that one. Sorry, this is sorry, this is the one. Depending on your choice, there's no obstruction. There is no bar. There's nothing. Means you can use any one of two. Only for explanation I'm giving you this. So I'll remove this because both you can use any one you want. I'll remove this now because that's controlled like this. So what I say sum. What is sum? Let's say 5. Let's say 5, 6, 6, 9, 8, 10. You can say 10. You can say 11. You can say 12. Like this. So these let's say. These are values. I'm giving values here. Values here. Values, values move like this, and these values move. I'll just put here for your just better understanding. I'll put a table mark, and that's the one. So this one. Now I want some of all these values. Let's put them in center one. I'm sorry, not like that. Let's put in center one here. The center one. Now I want sum of all these. How to do sum of all these? Point is that let's say what is sum here. I say add. Sorry, I want sum. I'll do sum that one. Let me say sum equal to what? Let us say sum column. Sum column is here. I'll say formula is here. The answer is here. I say answer is here. Answer is here. Okay, this is the answer. Now add sum. Remember, add sum and sum and sum, and I say this here, and I say okay. I take all these cells, and value also here cell is there. So what's there? Answer is sum D4 to J4. D4 to J4. This is sum. Okay. I'll say deduction. Minus, you can say deduction, you may not understand. Minus all. Let's say minus. So what I do? Minus. In this case, again sum. But or you can indirectly take this value. Let us say how to do it. Let us say this way. Let us copy this first. Let's say minus, there is no minus formula directly, so we will say this minus this minus this minus this minus this minus this minus this. You can say this cell, I think there's some error in this because hold on, there's an error. Let us say, because we have to deduct all this in this way, it is direct. So you can say d5 it is. So let us say minus d5 minus d5 minus e5 minus f5 minus g5 minus h5 minus i5 i5 minus j5 minus k5. No, k is answer, sorry. j5 is okay, j5. So this is answer. Here is minus 61. Because value is same, we are taking negative direction. So it's minus. Simple. Now let's do different way. Let's say algebraic sum. Algebraic sum. What is that? You know. What do you mean say? What is algebraic sum? Algebraic sum means whether it's plus or it's minus, it will somehow. Let's say this value, I say minus 5. Let's say minus 5. Then I say 6. Okay. Then I say 6. Okay, 8, 6. Right. I say minus 9. I say minus 9. Alright. Then I say minus 9. Then I say 8. Then I say minus 10. Then I say 11. Then I say 12. Let's say 12. Okay. I want, there are no two or three negative values and other positive value. I want sum of them. So sum is same, formula is same, no difference. What I do here, I took sum already, so no problem. We'll keep this. We copy that one. Copy here. We'll find answer is 13. Or otherwise you can say same formula, some decision. So use sum of this. Algebraic sum, just for explanation I'm calling algebraic. There's no way of calling sum. You can take minus plus whatever value. You can take them, there's no problem at all. Not at all a problem. You can simply say like that. Got it? So we have gone through sum, we have gone through minus, but remember, for minus you have to take each value, but for sum, plus minus, whatever, you can do that. And for multiplication also there's no problem. Let's say multiplication, multiply, you can say multiply, I say multiply, there's no problem. We have product value, this all I copy here, this plus minus all I'm taking down here, and you know, I say product, add product, multiply is simple, product, and there's another way also, I'll tell you. Product this one, I'll do this one here, and you know, values here. This is value minus because there are one minus and three minuses are there. So minus and minus make plus, one more minus come. So it is minus, minus. You can multiply all them and you can find this answer. Now that's one thing. Also another point. If I want to divide this multiplication, I want to say division. Very important. You can divide any number. Let's say easy division. Now what to do? I want to let's keep same values here. I'll get to say so these values here first, because it's better to be simple one rather than complicating everything. Simple one. This one. Now I say I want to divide all of them. Let's say first of all I want to divide all of them. Not easy because there's no direct formula for that, but we try. What? Plus this divided by this divided by this divided by this divided by this divided by, you know, H8I and divided by J divided by J8. J8, what's that? You got all the formula. You see value here. D8 divided by E8 divided by F8, all out of D8. This is a formula, answer. So, here are values and here's answer. I'll put answer little, in different shapes so that you can understand, and I'll change font also here. Let me do it times Roman so that it looks nice. So it's here, you have an answer. So this is division. Now this is division for all values. Now let's say, okay, I don't divide all them. I divide the same different way. Another division, I'll say, let's say I put only these 11 and 12 and take them here. I will divide them. What to do? Plus this 11 divided by 12. This is answer. Simple. Let's say other one, because here all 0. If you accept 0, you will not get any answer. So be careful. Now division is let's say division, another division I say. Let's say I say another division, and that is, let's say I divide these values here. No, sorry, not here. Sorry, I'll take these values first down, so that I divide here. Because row is separate. Now I want division of 6 by 9. So what I do? Plus 6 division 9. This is our one. Okay, this answer. Or I want to say no. I want 6 and minus 9. Okay, I change this to minus and put it here and get this answer and minus. Complete change. Or I say, okay, here I use this. Let's say 11 will be minus. 11 be minus. Put this minus here and you get this answer. Simple. Alright, that's one thing. If I say no, in this multiplication, all are minus. I want to remove minus 9. I want to make it plus. Remove this minus, you'll get a different answer. The answer is different now. Or if you undo that, you will find same answer. Similarly, here you have to have all positive values. I say, okay, I have 11 value minus. So I put 11 value here minus. This is complete formulation. It's called automation of formula. This is called application of formula. So we have understood sum, we have understood minus, we have understood algebraic sum, we have understood multiply, we understood divisions, and now we have to, let's say, square root. Again, it's not answer square. Let's say power 2. Power exponent 2, you can say, power 2, you can say, power value, let's say, power value, whatever power it is. Let's say this is now, for example, I say I can put value here. Let's say this is power here plus 61. I want to use power 3 here. Let's say power 3 here, power cube, you can say power 3 here. You get this answer. So simple. You get this answer, power. I say this is power answer. A same power you can calculate for this one. So just put down here. You'll get same answer here. You can go down here. You'll get same answer here. You are going to use power values here. And if this power value, again you can say, if you want to select the cube, you put here. I'll do something else also. I say that, okay, you did that, but I want to say this power here. Cube I want to put here. I'm just telling you something else. I want to put here, and I want to plus this, plus 3, plus 3. Then you go down and you see, I'll say this one and 4, this value. So this value is here. There are so many ways to do it, but what I'm doing is, let's say 3. Let's say I'll say 3 itself again, and let me all value 3, so that you clearly are not confused otherwise. I am doing different type of power. I want to find value of 3 in this power. This is my power. Now this one is already I've given you, or I say I want to remove that value. In different fashion. I want to put another power on this. So power again. I say again power value this is, and here result of this, the power result, this power value. I say power value, and this is, I'll say power value, and then I'll say, you got my point. Power value I'll keep 3, but I'll say result here, power result here, and that power result is what? Let us say power result is, what is that power result? That's important point. power result is what? Yes, a power result. Let's say this value and this power I want. So I'll say in bracket, this is value here. This value is already there we have. And I want this value to this power. So what I do, I'll go to power sign, that's power sign, and put this value here. I got this. And not only for this is for all. This is for all, regardless value. So I can say I have done this, and you can write any value here. You can get answer. There's no problem. This is formalization. This this is called formalization. It's called application. Or what we have just said. This is what means. You go how I'm doing. I think you're getting what I'm doing. It's so simple. Maybe you're tired of by now. Your brain may be heated up, but it's really interesting. Interesting to see. Means these are the basics I'm telling you. Now this power which I'm saying 3 here, which you use automatically, this 3 not necessarily you put here, you could put somewhere else. You get answer. No problem. How somewhere else? Let's say this is 3. I remove from here this 3, and in place of this I put here. So I got same value here. Right? Let me see again. Value. Yeah, you got my point. I remove that 3 from here. You see, I use M4. So this power, same and same this. Now what I do, because I remove this, I want to remove from here. So what I do, I copy all this. You see, if you see this cell, this is power M4, this is power M5, this is power M6. This 3 has gone. Now benefit of this is when you are keeping separately, what we do, if I want to make it 6, let's say 6, you change value. Simple. You want to make other one 4, you change value. You want to make a 0.5, you can change value. 0.5, 0.5, you can change value. If you want 2, you can change value here. So in place of 3, I want 1 over 3. Okay, 3 or 1 over 3, one and same thing. So you can say plus 1 over 3. Let us say 1 over 3. You change this value. Say 3, I want this 9. So you get 9 value here. So if you have 3 or 30, you can get value. This is the benefit of this. This is called formula automation. Means automatically it works. It's 6, you got 60 now. It will work. Don't worry. If you want 1000, it will work. Maybe I think number problem has come there. Let me just change that first. Some error maybe there. What result is there? M4 is there. So maybe some result number L4 is here, and M4 division. So this is not taking a number. There is some other error it is. So let's say that one. There's some scientific error. So no, don't do that. So this is what we are getting. So if you just keep, let us say we will come back to same value, or we go to 3 value. So this is now 3 value, but I want know that one. I want M4. This is what formula is about. I think maybe we could be back to previous table just to understand again. Go to previous table here, and that's table here. That's this. I'm sorry, this table is here, and it's here. Yes, if you go see that this table is here. This table is very, very interesting. If you can use this now, this whole is there, and what I'm saying is, if you remember, I tried to give you some numbers. You remember, I opened the file, and so that you can remember. What I did is in that I think there was some formula here, and there was point here. I tried. If you remember, I told you some time back about this. This file. See, this was file for applied special numbers, and I browsed through you all this, and also you got sheet 2. I browsed through you many values here. All this based on such calculations. And if you go back to this, for example, this table is there, and it's not simple table, it's complete formula table, mathematical formula based on Excel sheet, Lotus 1 to 3 combination, And this is why I'm saying combination because I'm not using equal sign, I'm using add sign, add, which is much more efficient. And if you see same table is here, and if he is going up to the value of yes, say I can take it for example more value, it doesn't matter, you can take it more value and it shall work. Let us say you can see, you see it's going to 1700 is gone, and I go to whatever number I can say 1787, it's gone up to 1900s, 1960s, and it's gone up to all values. You can see 96, and it's gone up to values 2000 something. So this is why I'm trying to say, if you can see all values change, nothing remains same. A complete calculation automatically comes in. It's like it's something very very logical and reasonable calculation method to avoid time and maintain accuracy as well, because your calculator cannot do that, but you can do that. Now in this table, it's also very very interesting to see here certain values I put in. These are free cells actually. For example 30, I'm sorry, here C3, D3, E3, same way N3, and this all that. These are free cells. How we use them? Let's say for example it's 3155. I make it say, okay, I don't want this, I want 20 here. Let's say values have changed, and not only changed completely here I've said, because this is see again, you see again what I'm saying is, see 30 goes to 20. So here formula changes because it was connected here too. So here it also changes. 20 plus 14 is 34, plus it was 34, 50, 44. So complete results in down area, in lower area would change. That's beauty of such formalization, and that was only reason that I tried to give you book for Lotus on the revival. This tree. Now can you imagine if you see such calculation in book, how many pages this has been? Can you imagine that? How many cells are there? If you see go here down, you will find how many 1200 pages. I mean 1200 rows, and how many columns? One A to Q. These are about A to Q 9 columns. No. HI is 9, I and then 9, 17 columns. 17 columns in your book page, can't you have? You need at least 2 pages of this. 2 pages of this, and 1200 rows. You understand how many in your one page? It cannot take more than 40 or 30 rows, or maximum let us say 40. So this is 300, 30 pages. So this is 30 pages with 260 pages are there. This is calculation that would require 60 pages of your A4 size book. Getting my point? You're getting my point? It's no problem. It's very very easy, because it's something related to everybody. It doesn't mean only for engineers. It means for you. You will not find such calculation in any book. This is called expansion of calculations, expansion of formula. This can go to whatever number. There's no limit. You can go as far as sheet is there. Let's say I want to copy from 1207 to 1500, means I say copy, I want to pull it down, either pull it down, best is pull it down rather than writing formula, pull it down, and you can say let's go see here is 3361. So how many pages we added? Be just intelligent enough to understand. Go further down. Yes, it can come with level of resource. Okay, so this says available percent of the strength in this 97. You can try on your own one, because actually this is 97, so it is not having that power to pull it, so is refusing. But you can try your new sheet. You can see up to let us say I keep it only up to 333. Let me take it off better, because it's not accepting anything. So we can destroy calculation as well, no problem. And I can say I can say that let even this line has to go, so I'll delete that one, doesn't matter, you know. So up to 3333 we expanded successfully. 3333, just imagine how many 3350 divided by 50, and see it is 60 pages into 120 pages of calculations. You know, once I was very troubled in 1998 when I had to write my book. My book means, if you see, let's go control home, you can say, let's go to control home, and this is the one. Well, I think you got something. And that time I was doing this, you know, when I say book one, this book one, and this you know, this is now on Excel, but I was learning in 1990, I think this 1908, 98, and I wrote a book also that time, applied spiritual numbers. I was very much confused how to you know formalize that book. So I discovered this formula at that time. This formula which you are watching here, which you are viewing here, all this is that formula. You know, what is that formula? Yeah, I'll just try to say. See, if you see this number here, this is 1, this is formalized number, this is formalized, this is number like free cell, you can say, and these are also free cell. Now what I say, this cell, and this cell, this 3 cell, it is a result of this sum of these 3 cells. And you see this one, this cell B3 multiplied by 6 plus 2, and there are so many other formulas, this is all that formula. Now what I hear is B3 into 2, you know, B3 into 2 is there, B3 into 3 is there, B3 plus B11 is there, and this is what? Sum of this. Sum of B11 is this, and this, the result. And similarly here, so this is your B11 plus 1, this is your C11 minus 1, there's a formula. So this sum is same, and then this is super sum, which is all these 4 are added, you get this one like this, and average is this, is average of this. So this is table here, this is called application table. Application table, remember, this is one, this is second one, it is same, this and this are added together, you get third table here. You got my point? This is one table, this one is one table, this one is another table, this one is another table, this one is third table. It's combination of both two. You can see how 86 and 89, 175, sum of this plus this, 44, this plus this, and this here, this plus this, and here this plus this, and here is this. So this combination of these tables, this formula you can evolve wherever required, and that is basis is this. Yeah, I explained to you. Maybe you are that tired and you are so much heated up how to remember everything. There is no need of memory. There is no need of memorizing anything. Simple as this. Say very simple. Very simple. You can change anything in there. Don't worry. Its value is 5. I say it is 9. It's 9. What's the problem? It's 9. No problem. You will get this answer. Where it is there. Or you undo this, you will get same 61. You redo this, you will get same 65. You take a 9, so take a 90, you will get answer minus 42. So this is benefit of this. Don't say it's addable, this is formalization. Yes, formalization is very important part of calculation, and you should understand this point. If you can understand this point, you can understand anything. No question, why not? You have every you can say easy way of in engineering or in mathematics, or yes, it's not only you can say it's all not only this you have sine values, cos values also. I think I have one on the file, I don't exactly remember. Let me see if I can get you the file today. That is let me see if I can that is, of course, it is yes, I remember, it's not question. I'll just get you the file, maybe you are getting that. Let me see if you are able to see this one. If I are able to see down, let me see if you can, because that's a very important file, very very important file that is, and that is here. I think that is. I have switcher numbers, which I already showed to you. I'm not talking of switcher numbers here. I'm talking of something else, and that is scientific formula. Channel. I don't exactly remember what it was, but it was somewhere here. It's long back. Switcher numbers entertainment super macro. Let me see what is that one. Days. Oh yes, days. I'll shoot days first. I want to show you. That's also very important because that gives you what actually days number series days. Let's say days, and it's how many days old you are, and a switcher number effect. This is something extraordinary. What is this actually? If you see this is chart, you'll find enter birth date and you add serial number one, and let's say a free cell I have written. This is a month, date and year, MDY, month, date. I have to say date, month and year. I'm sorry, that's something else. So month, date, sorry, date, month and year. I just change here, and this is a day serial number. This is one day, the day you born, which day you born is number one, number two, then 1001. So I have taken up to 1001 column, depending on requirement, depending on availability of space. You can see this here. You may see this here. This is, I'll just pull it down. So you see what I'm saying is, yeah, this is here 10,006. I'm sorry, 10,006. 10,000 I've taken. The other one is, how many rows? 10,006 rows. And if you go back, control home, I go control home. So you see 10,001 is other day. So similarly here 20,001, 30,001, 40,001, 50,001. So this is number one day. This is 10,001 day. This is the 20,001 day. This is 30,001 day, 40,001 day, 2001 day. And these are your current time varies. Let's say it's 31. Let's say now 15th August. Let's ourselves 15th August. Let's say 15th August and 1947. Let's say our country time, country independence. It's day one. 15th August 47 is day one, and today we are where? Today we are in year 2020, right? So we have to go to where? Think of. We have to go to in MD year. See, it says your first 74, 75 year. So this is 2 year, and we have to go to 20. So we will go to year 20 here. This is year 2. We have to move fast, right? We have to move fast. 20 year. 9, 10, 11, 12, 12, 12, 12, 12, 12. So we'll go to year 20, which is now we are in 11 month in 20. 11 month, say today is 2, here is 211. This is 211 here. This is 211 here. And this is 26,744 on November 2nd, 2020. We are 26,744 days today. You can calculate yourself, no problem, because how many years old we are? So 26,744 days today we have covered since since independence, since our freedom date. This is what it gives. Now you can check your own, whatever date we have. Let's say for example date of birth was 3155. So if some person is born on 30 January 55, how many old that person today is? How many days old that person is? So again we'll go to 20, 11, 2011, and today is second 11. So this is second 11. 24,019 days old that person is. You got this file. Again, I'll show you this file. Such kind of, this is not magic. This is simply of application of your, you know, formula. This you can learn with. I'll close this file. I'll try to find something else. Just for your information, I wanted to show this. This was not actually part today. No problem. No problem. I'll find different file if I can, because when I use Excel, I cannot move to some other program. There's also restriction in this document share. So I do number explanations, number data formula. So I say problem is that there's another one I show you, hypothesis. Let us say this hypothesis, which is something further complication calculation. What is finding something? I'll show you. This is some program I prepared long back, and this very important one. What it is giving is, you see, it's giving is number data, chip capacity, chip of what? Chip, silicon chip, or you can say a computer SIM chip. SIM. This is certain calculation which is your brain is considered chip. If I consider your brain as chip, this calculation is answer. Why I say brain area here I'm considering 200 square centimeter. 200 square centimeter brain area here, and this oracle diameter. Oracle means what is value of your mental capacity, what is your value of your mental capacity that pulls in how far your mind can reach mathematically, magnetically, electron magnetically. This is that value. It's not some tedious. What I'm considering here is 200 square meter sim size. Sim size means sector of sim. How many sectors are here? So if I say chip capacity is say just 0.1, 10 centimeter, or little less or less or less or less, and going down in minus, then it's going in plus, because 0.1 is 10, 0.0 is 100, means reverse of that. So this is projection of your brain, just like projection comes in your television or in the computer. So this is imaginary in a sense. It is minus power here. There's a minus power. Let us say 0.1. If you reverse it, it is 10. 0.01 versus 100. So this is a projection here. This is a projection, and this goes on increasing while this goes on decreasing, because this is a E minus and it is E plus. So this is going on decreasing, and I consider 49 here, and I've taken up to 60 value of this. So it depends upon how fast you can brain, how much use. Now this is giving a square meter here. Square meter of some size means I'm saying spherical size. Spherical size. If your brain is 10 centimeters square, you'll get this size square meter, and you get this size of your brain area, and oracle diameter is this. And generally we consider 10 to power minus 6. Micron we say 10 to power minus 6, and which is minus 6. This is 1, 2, 3, 4, 5, 6. This is the power. And when this is power, this is the power, we'll find about 80 meters 80 meters size of your oracle. 80 meters. It's given kilometer, that's why it's 80 meters. And if you increase it by your power, you'll get then 252 meter, then 797 meter, then 2 kilometer half, and nearly 8 kilometers, then 25. Like this, if you go up to 55, you will find here this one. This is 2.52 into 10 to power 23. You go to 656, you'll find to 7.9 into 10 to power 23 kilometers this is. And if you go to lattice 60, you'll find 7.97 and 2 power 25. This is all further projection of this in simple terms. This is a projection based on such mathematical calculations. And this is why I try to stress this. How can you use this why I have done this. This is really extraordinary. There's no checking system. I'm sorry. So I am closing this file as well because purpose of this file, just occasionally I brought it to you. So now it is original one, and this is book one, and this one again I say number data I showed to you, and now I think that file has disappeared. No, not disappeared. It's here. So this is mathematical formula. Yeah, I understand. I feel that you must have some understanding of this. It's already 1 hour. Whatever, I continue because this is a specific day for me. I wanted to give you this information, and I think I was for searching for which formula. I forgot again. I wanted to show some file. Anyway, I'll show to you other files as well. Yeah, I want to show values of sine technology. I'll show you somewhere else. No problem. I'll try to show you that somewhere else. Now you can expand this if you can't read this. It doesn't matter. It doesn't matter. You can zoom it and explore it, or you can see. I think people may be getting what I'm saying, not necessarily they no, there is another way as well. I'm not wrong. I like to go back to this book one, page sheet two, and there now. What I'm saying, let's say, uh, means it's not this end. Means there are so many ways you can formalize this. Let's say, how can you formalize this? Means, let's say, how can you formalize this? That's understandable. I'm taking this cell, this different kind of calculation I'm trying to show you, which is, let us say, I say at some, let's say at sum, and I say these three cells I put in sum. I put these three cells in sum, and answer you got is there, right? I put this let's say also I put there as well, so that it's a little clear. I put this value here, a specific comment, and you just what I'm going to do. I'm not sure, and you all just watch what I'm doing. This is sum here, sum of D4 if F4. This sum is there. Now I want to teach something differently. What values are there? 9, 6, and 9. 9, 6, 15, and 9, 24. It can be different as well. If you put 10, you will change this value, right? It's changed again. No problem. I'll go back. Now, why say I've done this? One sum. Let's say another sum. Add sum. I say these values, right? These values is this. I'm sorry, but say no. I did not use this formula. Okay, fine. This parenthesis is missing. I say okay, fine. All right. Now this is value. Sum D4 F4 plus sum H4 J4. These three and these three. I can change any value here up to J4. Let's say 25 it is. So this formula changes. Answer changes. So here I would say undo, and I'll first write answer here, so that you may not confuse. You may remember what I'm doing. Answer, formula answer, unexpected formula answer. I say unknown formula answer, unknown formula answer. Just I written this because you may not confuse what I'm doing. Unknown formula written here, so it's not unknown, it's just known. Just for this I'm saying unknown formula answer. Now it's 57. What we have done? We have done sum of this, and we have done sum of this. This is one part of answer has come. Now in same one we say okay, let's say plus add product, product same. So I said product, sum plus sum this, and product D4 F5, and plus also again I say product formula, this and this, and again this, and I get answer. Got it? I use one, sum, second sum, then production, and then product. Four formula are combined in this. You got my point? I combined same four formula, sum three cells and sum three cells and product three cells and product three cells. We got result here. Now I want to further amend this. Why do I say I'm not happy with this? I want whole this one by something. I want something else. What? What to do? To think of what can we do? I want to get, you know, division of this by some value. Let us say which value. Let's say this formula is now, I put another bracket on whole formula, this one, and I want to divide it by value here, which is in power value 3. I want to divide by this. It's not power value, but I am just using this. What do you want it? You know, you see this formula, sum, then product, and you are divided by some value. Not necessarily this value here, it could be somewhere else also. Let's say if you have, let's put this value here. I'll remove this value from here just to avoid confusion. Let's remove this value from here. Let's remove this value and we come back to previous formula. Now I put here some value in this cell. Specific, I'm writing it specific for this formula. Specific for this formula. Alright. Specific. So it's specific. I say 5, let us say 5 for now. Let's say 5. I say in this formula, I use division by some value, and that is my 5 say. This is 5 say. This has come. Now I say I'm not happy with this. I want something else. I don't have 5, I want 8. Okay, don't worry, because this is free. I use this 8 and get this answer. Right? Okay, fine. I said this okay. Still I have this one. Oh, I'm not happy with this. I want square root of this, or I want cube root of this. So in that case, what I do? In that case, let us say a specific value I can add here also or here also. What I do? I can just put inside a column and a specific one. I can say specific 1, and then I can say okay, specific 2. I'll take a specific 2 here and say okay, I want to use some value. Let's 2 value here. I say I want whole this answer in square root. I mean to square. So I say another pack. I put here another power, another, and also this all complete. I put here, and what should I do? I have to do power game with this value. So this is answer. You got my point. And if I want to change, no, I'm not happy with 3. I want 1.5. Okay, 1.5 answer is changed. Got my point. So how many factors are here? You see, sum, then product, then division, and whole answer, and then there is power. Let's say, oh, I'm not happy with this as well. I want another power. What another power you want? I want 8 power of this. Okay. Now problem. हाँ? नहीं, मैं इस पे बात कर रहा हूँ. Another, oh sorry, this is not that one, sorry. So I say that it's this one and this one and this one, both. I completely close bracket, new one, new boundary of bracket, and say okay, I want power here 8. Oh sorry, missed one, sorry. So this blank has come, some error. So I again put that one, 1, 2, 3. I mean, problem is this brackets, you know. If you don't use them bracket correctly, you will lose something. That's another point, you know. I use a bracket and power game, I missed that. I put power now and I say 8, and you see this is the answer. You see, now it's going on expanding in a scientific way. You got it? What I did, sum range of 3 cells, sum range of 3 cells, product range of 3 cells, then all added and divided by some value C4, that is specific value, and then power was given to D4, the specific value, then again another power C4. Now I can change them. Let's say I don't want 8 here. Remember this 8, if I change this, then another way, that is C4 somewhere here. It will also be affected. Just remember this C4 is there. I'm touching C4. I'm saying I want 6 here. So you will find 6 completely. Answer is changed. Or say no, I want same. So answer is again same. If you say no, I want to check. So use 2.68 value, and now it's checked again. Oh, I'm not happy with 0.5. I want 3.5. Okay, 3.5. This value. This is called formula design. This is called formalization of calculations. Don't stop here. Go further. Okay, fine. What I do? Oh, I did that, but I want some E4, G4 to some value and then continue formula. Oh, that's all. So what do you say? You want this formula to be added a value, and here I say, okay, I add value here. I say its value here to power, and I say just to do one thing, add 3.5 here, and I add this formula. So you see, it's expanded further. You got me or don't get me? Okay, I'm not happy with that. I don't want D4. I want here also some change. I want here also some power. Let us say here also some power, and that power is 8. See, you're going to I'm sorry, some error here. So don't worry, no problem. So why say, you say okay, fine, it's all okay. I want this answer to further, 1/3 root. Means, what do you say? Your answer which is here, your answer is there. I bracket in this answer, and I say I want power to 1/3, because I'm not given any 1/3 power. So I'll take manually this power, and this power is 1/3. I can say 1/3, and this 1/3 we can change it later on. This is answer. थोड़ा गर्म पानी हाँ
मदन से
नहीं तो
करता है ना फेस
तो करेंगे जब कर लेंगे कभी। अब सोता रहता है तो क्या बात करते हैं उससे।
आज थोड़ी सो रहा होगा।
चल कर लेंगे ना कोई अभी और
क्या कह रहा गर्म पानी?
गर्म पानी थोड़ा आधा कप भेज देगा, वो ले आएगा
पीने के लिए।
हाँ। So what I was saying, so now this result here is power of 1/3, which can further be say, let us say I don't want 1/3 here, I want 4/3, so I can say 4/3. Let's say 4/3. Again there's some error, I think sometimes entry is a problem, Let's say 1/3. I say in bracket I can keep this also, so that in bracket it is values and remain same. Let me first see this value same, this value same. So I see here, I say 4/3, so I say 4/3 with this value. So you see how complicated formula we have made it. Can you analyze this formula now? See, how many brackets? 1, 2, 3, 4, 5 brackets here in itself, external brackets. 1, 2, 3, 4, 5 external brackets. How you see, if you see initial sum 1, 2, 3, 4, 5, if you see other side sum, you see 1, 2, 3, 4, 5 external brackets, and then formula arrange some bracket, and then another sum bracket, then product bracket, and then division, and now sum, and so much. So do you understand what we are doing? We have done nothing, we have done a lot. That's what power of formula is, and that's what I'm trying to say. You should use your common sense, your mind, to understand what we are doing. That's very important, and you can move very fast in calculations. So if you do undo, means all will go away. I don't do undo in this case. Now what I will do, I will do something different. Let's say what's that? Let's say what's that? So what I do, I'll add some value here. Let's 5 here, 6 or 3 here, whatever, some values here, or I can say, let's say 5 value, 4 value, 3, 6 value and 4 value here, and let's say 3 value here and 3 value here, and let's say like that, and let's say, let's try, can you get something out of this? And if the how many four rows I've taken, you see, except some, maybe some error in some, that's why I removed that. So let's say other formula is there. So same result is coming for this one. Unknown formula which was in this row 4 is now in this row with different 6 and 3 values are there, 9 values are different, so answer is different. And if you take like this, you solve. And here I think this was some error. I'm not sure why this error was there. Maybe computer capacity is out, so it said I can't take it. So let's say, yeah, it can't take it. Formula is there, there's some other error, so we leave this one. What I'm saying is that friends, your formula can be so expensive. It's expandable formula. What I mean to say is that I'll just change present tense. Uh, it's powerful expansion. It's not simple expansion. It's very, very powerful expansion for calculation purpose. And we say, that's what we say, that how to save time in calculations, and particularly in engineering calculations and other calculations. You can change whatever value here, and you can find answer. And maybe you are confused now, I'm sure, but confusion doesn't matter. And again, I would say very, very simple way is that I'll explain to you again. I explain to you sum, auto sum, and then minus, or reduction, you can say, minus multiplication, division, because I have seen many people, they don't understand mathematics. So best is this one, division, sorry, spelling is wrong, division here. So sum minus division, power or exponent, you can say, exponent, power or exponent. Power or exponent, तेरे को नहीं कर रहा हूँ. Power or exponent. So these are basic, if you know what is meaning of sum, what is meaning of minus, what's meaning of multiplication, and what's meaning of division, and what's meaning of power exponent, and algebraic sum. That's very important part, algebraic sum, because without that you can't understand icon, I think. Algebraic sum, let me look some water. Algebraic sum. That's important. These standings, if you have like kids in school, they do mathematics, arithmetics, you will get a lot. Meanwhile, I'll go back to the order. You can go through this and see what I've done yourself. I'll just show you change means how change works. Let's say 1000, 100. You'll be surprised to know how values change. Sorry, not this one here. Sorry, in 100, I have had in 100, this error. So 100 is free cell, not 200. 200 I put here. You see, everything has changed. Everything has changed. Everything, you undo this, you'll find change here. It's called application. Once you do it, you will never change it. You cannot. You will just change your free cell. And in Excel sheets, you can close that cell as well. I mean, you can close all of the cells so that this will become uneditable, and you keep this cell where your value is free, or how many values you take. You may take not one value, you may take many number of values if you link them to a formula. For example, here cutting apart find 5.6, 0.7, 0.8. You can take them separately and you interlink to that one rather than writing 0.5, 0.6, and all results will be same. Now, it's your interest, how much interest do you have in calculations, and particular to those like having relations who don't know what's mathematics, yeah, for them it's very easy, means nothing difficult, means how to write countings, means as said counting, it's counting actually 1, 2, 3. Just formalize it or pull it down. Means pulling is very very childish game. So you copy like this, like copy paste you can do where you do, it's no problem at all. Copy paste is easy, like I'll show you, means before going further what is copy paste. For example, this is 1 and this is 2, this is 2. So what does it mean? This is counting, but why not to formalize this? Why not to formalize this? Question is that formalize it, no problem. So I say there's one cell, one value, two value. Now what to do with this? This 2 comes because I add 1 to this one. So I say plus this cell plus 1 is this one, right? So it becomes 2. Now rather than this value, it becomes a formula. Now cell, this J21, it was a value 2, now it's a formula. So what I do, I can copy it further. Let's say copy this, let's say at copy, let us say copy. I think a command is not existing in Israel. Let's say copy cell this. Not functioning, this is not giving that function. I think Lotus was better than this. I'll show you how to do that. Copy and paste, that was copy from this range to this range. Let me try wait and take this one, copy cell range this. It's not taking problems. Excel is master, this is copy on the Lotus is master. Well, you can even then you can put here, you can 3 already you can there. So you can go this, as I told you in the beginning, that is the harm, and then you can otherwise take in different direction as well. So you can move to whatever value. I'll go with you. Now I want some means formula. You can say basic calculation, basic formula. I will do this, means how to do, and this means basic formula. I want to use this times Roman, so it's up to you, means some just to I know for clarity, means some minus and all this, also here I'll make full just for clarity. Solve this, and here also I take times Roman, so our things looks very side now. With this sum, for example, you can take from auto sum here, but it's not necessary. In this you get sum, you can take average, you can count numbers, you can max, your minimum, more means this is very ordinary functions. These are not all functions. There are also average, if, hyperbole, hyperlink, count, sine, sum, if. So these are different. I'm not going to this. The purpose of formula, purpose of application, I'm not using them. I'm just giving very very basics. Now here is sum. Let's say let's say this value, you have taken 5 values. You can take any number of values, doesn't matter. and you know, also you take this same value for minus purpose, because we have to do minus also. Multiplication also we have to do, so we'll take image all values same now for this purpose. And even division we will take same values first, so you take division also here. Power exponent we have to see how to do handle that, for that we'll see. Now I'm just taking same values here, so just for reference. Now I'll change them, don't worry, I'll change them all. So it's this one. Now what to do, how to handle this, this point here is how to handle them. You have to sum the minus the multiplication, for minus, there is no standard formula, so we have to apply cell connections together. We can't do otherwise, and this is value, I should say this is values, actually I should write here so that you do not confuse. Values say in this, and these values can be copied further. So this is value, I'm sorry, this is here, 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 and here. This value is not copied. What to do? You want sum. You want sum according to auto sum, or you want sum according to our formula. Look, I'll just show you auto sum, otherwise I'm not interested in auto sum. I've written sum, that's only purpose, but this because auto sum is there, no problem. You can say auto sum is there, and you say this auto sum 140. It's very easy, there's no problem in that. Auto sum is very easy, you know. But that is a restricted formula. It doesn't give you freedom. We want freedom from that formula. We don't want to be bound by I mean to say, by this Excel software design. No, we want to be free. How to be free? That's its answer. Result of answer, I can say answer or result. I don't want to be bound by that, because this formula is same. If you see this answer is sum, this is S3 formula is same. There's no change except that this is a minus, and I was using add. So I say okay, I forgot that one. I use same formula with add sign, right? So answer is same. There's no difference. This will both work. Still they are using add, but it's sum, because basically hidden is Lotus 1 to 3. It's copied program. Let's be very frank. Now this is sum. This is sum. Now minus. I say minus this. So what I say, I use minus. Minus all. I mean to say, let's say start with plus. So plus, then minus, then minus, then minus, then minus, then minus, then minus, then minus. Minus means x. So x for sometimes, at end it doesn't work, so we use this is you can say T4. This is plus. This is T4. This is formula answer is T4 minus U4 minus V minus W4 minus X4, or we say okay, we take this also minus, so it doesn't matter, you can take minus. So answer is different, answer is same, only difference is minus. Yeah, 140 was plus here, 140 is minus, but you can change, let's say same values first, multiplication. Now there's no direct multiplication formula, so as I said, these values are to be multiplied. Now we had added these values, we subtract, added in minus sign. The minus addition, you can say minus addition rather than blank. Minus addition, you will confuse. No, don't be confused. Minus addition is this minus 140, or if I sign here, if I write here minus, already I have taken minus. If I could not take minus, then it will be algebraic sum. So that's why I'm not writing here. Now answer is same. The multiplication, I have to multiply all this. 1, 2 value or 10 values or 50 value, it doesn't matter. So I have to say add product. product, add product, and that's this one, and this one is our product 873600. This is our accounting formula. But this other one, let's cancel this. Let's do other one. I'll show you here that one better. Let's say this value multiplied by this value multiplied by this value multiplied by this value multiplied by this value, and you get answer. So both are same answers, there's no difference. But here you have to travel every cell and multiply. There we are not going to travel. You just put formula and do it. Put for formula and do it. Put for formula is same thing. Some example we can say, let's say sum. We don't want to use auto sum, we want to use sum. We say like this, okay. Let's say plus this plus this plus this plus this plus this. So answer is same. There's no difference. Just like we did minus case, answer is same, no difference. So what I'm saying is, this is how automation helps in. How automation helps in. So here we are using long journey travel, long journey. You can say long journey here. Long journey. Why to have long journey when you can fly? So long journey, why? Question is that why long journey? No need. Same with division now. Division, we have to divide. You divide how many division? You can't take direct division formula. So you have to do long journey. So let us say this is long journey plus, you see, this divided by this divided by this divided by this divided by this, and divided by y, because I'm finding some problem here, y6. So I can say divided by y6. I think there is some error. Why this error is equal to see 56 versus value solo, I think. So it's not giving. Okay, let's try again. There's some error, I think. If I say value 10.6, it will be, no, it won't come. There's some error here. Maybe you miss it. Sometimes you do some error. So let us see how to do it again. I put the same value there. That's the okay. Answer now. 56 divided by 65 divided by 5 by 8. Let's say how it says that this is wrong. That's what I say. This divided by this, which is equal to this. Values very low, that's why not giving. Then again divide by this. So values too low again. So we have divided by V6, then we divided by the V6, then W6. So it's too low, and we have to divide by this value W value X. Let's say X value. So this divided by further 6. So that's why it's 2 value 00359. So it will be now exponent. Let us say exponent. This is division value. Now we'll take exponent will be too high in this case because we are going to do expansion. But let's say exponent here. We'll say 56 power 65. Then power 65. Then we see bracket, and we bracket here, and then power again, power here, and we see 5. Let us see what value comes in. Num value. So it's not taking, it's failing in. Oh no, I did mistake here. Actually T7 divided by T7 exponent by C7. So let us leave bracket and see how does it work. Let us see how does it work. P7 here, and let's say no, it's not extending. So it's not that powerful. So let us say exponent, we make it 3 here. So it's giving value now. Let's say now let's cancel this formula and do it again. Let's say 56 divided power by 3. So this is answer. 56 to power 3. and then this answer we want to power 5. This answer we want to power 5, power 5, power 5, and this is this one. This answer to power 5 is this one, and then we want this answer to another power, and that's power 8. This is answer, and they want another power, this one here, to power 6 their value. So this is here again. So this here, here it's not accepting. This means, so we can say that this power is not accepting. There's some requirement here. Let's say 0.5. They're accepting, or it's not accepting the 0.5 even. So let's say it's accepting. So there's a problem in power. Let us say 1, 2, 3, 4, 4 powers are there. Let's say T7, then U7 to power 5, T7 to power 3, U7 then to power 5 into power 8. So this value means it depends on capacity of your sheet. This sheet is very old, so algebraic sum. What's algebraic sum? That's just an important point. Some value which you can take from here itself, same is there. Algebraic sum value is same, but what we do here, I'll explain to you what algebraic sum. Same power here, but now I say no, I don't want 56 here, I want minus here. So that minus, it works in. So you see minus 56 plus 65 plus 5 plus 8 plus 6, value is 28, right? So it's 28. This was long, this is actually short journey. I'm sorry, it's short journey. So I should not use this value here. I correct it, and I should have used this value in fact. This is short journey formula. Those division and power exponent not short journey. This is short journey formula. So here I say sum of this. Now I say already 9 minus power. Now I say power 5 is also minus 9, minus 5. I make minus here. So I say then 2.2 or minus 5, and now I say okay, 65 is also I say let's say value change 65. I say I don't want to keep 65, I want to keep 65 over 3. I want to change this value. How to do? Because this is here 65, I'll keep it 65 and then divide by 3 here itself. So you will see value change again. This is called algebraic sum. Means plus and minus you will accept depending on individual value. Let's say I multiply 8 by 3 here. Let's say I multiply plus 8 into 3 in the same formula, and I say value change. This is beauty of algebraic sum, that you can manipulate it anyway except division and power exponent. So in sum there are both type of formula, shortcut as well as long cut. Minus addition same, you have to do if and multiplication, you can use both. Here is long one, here is short one. This was this is what I wanted to I mean to say. This is beauty of Excel. This beauty of Lotus. You can say, I would not say Excel. I would say beauty of Excel, and beauty of Excel, and you can say so this formula is so. We even remove this one. There will be no impact on range. So we can delete this, for example, and we can delete this also, for example. There's no impact of range. All will remain same. Always same. So when you understand this basic formula sum, how to make minus, how to multiply, how to divide, how to power up, so you don't find any problem in your arithmetic. But now this is one part of this one. This is a very 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 elementary part. I will explain to you, very very elementary part, explain to you. We can jump on to further little complicated one, though it's not very complicated. It's little complicated. For example, I like to tell you something here. Let's say now, let's say what to do means this all free. I take these two values from here. Let's say up to here. Let's say to this value here I take. I put them here. I put same value and not to again right now. What are these? Why I have got this? I want to discuss with you. Now I want to discuss with you. Let's say there's a triangle. I say this is a triangle, a square. Let's say this is a square. or rectangle, and also this is triangle, 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 this triangle, or you can say what else, generally use triangle, and you use square, or let's start with this better. Now this is a figure, this is called figure, figure. Now what does it mean? It just means this: we have certain mensuration figures, we want to calculate their values, means their areas as well as their parameters. That's also what area and what perimeter actually is there. Area and this parameter, parameter. Parameter, so perimeter, we have say parameter, no problem. And then we can say, let's say 5, it doesn't apply to triangle, it doesn't apply to to circle. Let's say something else. Let's say this is let me write first for circle, so that we can understand what we are doing. Circle, circle. Now first we understand what we have done here, or what we want to do here. Now there are two ways. In we need to find square. It means length and breadth. Now one value, let us say these values are length. Now we can say this is length. Other value is breadth, or you can say meter distance, or length or width or breadth, or what you can call it, means in a way length or breadth in meters, or but I am not considering units here now. What I want to know is square figure, how to find area and perimeter of that. When it's square, you say when it's square, equal, there should be equal sides. So let us say a square means 8, this should also be 8, right, or 8 or 5, whatever it is. Area, how to find area? You can simply say plus here plus length into breadth. This is area. Area means square. Area means square unit. Square unit. Square unit. So what you have done is you find area of square unit. Square area is, area of square here is, you can say area of square here is, what I mean to say is 64, 8 to 864. It's 64, and perimeter what? Perimeter is, there are two, means this 8, all sides are equal. So perimeter is 4 times, because sides are 4 times 8, right? Or 8 length, 2 lengths, or 2 breadths, whatever you can say. Or you can sum up this and multiply 2. It's up to you, whatever you say. So let us say we will add 4 sides, so that we can apply to square, rectangle, both. So, or we say, okay, I'll take one more gap here. Why to confuse you better? We just cut it and put it here, and we just put another here, so that it be clear that I'm talking rectangle here, not square. So no confusion, please. Rectangle, it is rectangle. Now in this case 5 and 8, we can say 5 and 8, no problem, or 8 and 5, or whatever it is. It doesn't make a difference. It doesn't make 5, so we say. So we are not confused. In square, 8 into 4, we have 4 sides. So how to take that? That's the point. You have to either use some else unit, or we can say we insert another row here and take certain, we will say 4 sides for this, 4 sides for this, for 8, because sides are equal. It's up to you. Sides are equal, sides are equal. Let's just use for reference sides. 4 sides are there. So what we say is square root. We have to find a square root. We have already found 64. Perimeter how much? Is 4 into 1 unit, 4 into 1 length. So we can say plus into this, into this, whatever it is. So this is all right. 32, 8, 8, 8, 8. Because sides are equal, it doesn't matter. It's okay. So in square, all sides are equal. So we have multiplied that. A perimeter, this is AC3, this is AC3 4 times into Z. We got this, or we could otherwise also. Say at rectangle case, 8 meters and 5 meters rectangle. What is area? Area Here you see this into this. Here also we can say this into this. 40. Now here sides are also 4, but we'll say if you say 4 sides, then we have to sum up all this again. So what say because it's rectangle 8 and 5, we can say this and this are added together and multiplied by 2. So let us say that we say multiply by 2, and the parameter, how to find parameter? Then add these two values and then multiply by 2. So let us say plus bracket, we are using formula here, plus bracket, we add up this value, plus we add up this value, and we close bracket, and then we multiply by what? We multiply by what? We multiply by 2. So we get 26, right? 8 plus 3 26. Though whatever unit is there, don't worry about that. It will take automatically once you enter this formula. So even if you now 8 is, because these values are 2, so in square we can say length and breadth are equal, so we can say this is same. Now we have added here formula. There is no formula. If I make it 6, answer will change, So we have formalized the square, we have to formalize rectangle, we have formalized parameter. As a square, you can't change dimension. You can change, suppose I make it 3, it will change answer. If I make it 5, it will change answer. So this is also formalized. Now come on to triangle. You got my point or didn't get my point? That's my worry. I'm not speaking very fast, but we may say already 2 hours cross, no problem, hours no problem, because it is interesting and I think you find interest in this. Now let's go to triangle. What is triangle? Triangle, one is base. You can say, let us say, here if you length and breadth I written, here's no question of length and breadth. So we cut it off from here and we put another one here. So we say this is not triangle. In triangle case, we'll take another down vector. We have to mention here what we are going to do. So we have to show this is base and this is height, something like that. This is base, and this is height. This is triangle, is base into height. So we say base into height. All meter feet up to you. I'm taking meters. Now I'll take circle also separately because that is different one. So not to be confused with that. So I'll take circle here out of that. Now this is now base, height, triangle. What you find? You have to find area and perimeter. Circumference it will be, not perimeter. So I'll write circumference here. So rather than perimeter, so that you can't confuse. So it is perimeter, it is circumference. Circumference class. Area square unit circle. Now we have to find area in square unit, and that's a triangle. We have base 5 and height h, it can any value. What's formula? We say you have to base and height multiply them and divide by 2. You can say half into base into height. So let's say we use formula here 0.5 is formula coefficient. I can say formula coefficient. Formula, so they may not confuse formula coefficient. Okay. Problem is that once you write something, people should go couple. Well, I'm just speaking to you. This formula coefficient 0.5. What is the square root? Area. Half into base into height. So we have here free value, and here free value. What I should do? I should take plus sign plus half, what is formula, into base into height. So this is 20 units. So simple. And you can change it, don't worry. Just like you change there, you can change here also. For 5 and 8, it is half you cannot change because there is a fixed. This is a formula coefficient, I should say. I should write full actually, so that you may not confuse coefficient. So I'll just give more space. Formula coefficient 0.5, triangular formula coefficient, and you can say it's like that actually. So we have base 5, 8. Now make it 6. I say I make 6, so formula changes. No problem. Let's say circumference now. What is circumference? We say pi. We are talking. No, sorry. This is not circumference of a circle. I'm sorry. I did a mistake. Circumference is here, not here. That is here actually. This is circumference was here. I did a mistake. I'm sorry for that. This is not circumference. This is the perimeter. This is perimeter. Perimeter. This is perimeter. Perimeter of triangle. Are you fine? Perimeter of triangle. Rather than it's a mistake actually because they are combined together. So triangle now base height and this is base height and this is formula coefficient. Area we have found half into base into height. Well, I think should I write half into base into height or you understand that? I think you understand that. So perimeter. Perimeter means sum of three sides. So can you find that? We have only two sides. How can you find perimeter? 6 we have 8 we have height. So how can you find that's question mark here. Area we have. You think what formula is there? You see, when we have height, it's very complicated formula actually. Base we have, height we have. It doesn't matter. It's not given here as right triangle or which triangle. You can consider as right triangle, 90 degrees. So it can be 6 vertical, 6 horizontal, 8 vertical, and you have to find hypotenuse first and then add 3. What is hypotenuse? Diagonal is hypotenuse here. If you consider it's just right triangle. So we will say a right triangle here. I'm saying right triangle rather than confuse to avoid confusion. Let us say right triangle. Right, and I'll just give more space to this. Right triangle it is. Right angle or right triangle is the name. Right angle triangle you may say right angle, you may say right angle also. Right angle triangle. So it's right angle triangle to say. So 6 you have 8. What is hypotenuse? Because without knowing its hypotenuse or diagonal, we cannot find perimeter. We have 2 values, we don't have 3 values. You know what's formula? A square plus b square, or you can say base square plus height square. Sum of this square under root. You can find that formula. So it's very easy. Let's find it directly here. Let's say how. Let's say plus bracket parenthesis base square right. What's that? I'm sorry. What was it? No, plus bracket. I mean say parenthesis value 6 and its square plus other value this and its square, right, bracket close, right. We got something. What we got? 100. 36 and 64 are 100. This is one part of formula. It's not total formula. It's not answer. Answer is this is, we have to this square plus this square under root we have to find. So this is one part of formula. We have done base square plus height square. Now under root of this is your hypotenuse. So what is hypotenuse? Hypotenuse is under root of all this. We have this value a square plus b square under root. How to find under root? This bracket another one, this bracket another one, and you can say either 1 over 2 or 0.5 power, as you let us say 0.5, 0.5, and you will get this answer under root 10. Under root of 100 is 10. But this is not perimeter. The point is that this is not perimeter, this is hypotenuse. How to find perimeter then? Question is that. So we will say this is hypotenuse, this is hypotenuse, you can say hypotenuse or diagonal. Hypotenuse. So we will say this is hypotenuse, right? Or diagonal you can say, it doesn't matter because it is still let's say hypotenuse and we will find now perimeter. We'll go to perimeter. Now how to find perimeter of this? So you have to have a formula according to the requirement. It's not that it's already defined, not necessary. It's not necessary to define first, you just think of that. So now we want to parameter this. We have values. We have one value, two value, three value, and we have to sum up that. So what to do then? You have to plus this, this, plus this, hypotenuse, and you get parameter 24. This is one way. Or you can sum that up as well. That is how to sum up. I'll show you how to sum up this parameter. You can do otherwise, you can do otherwise. How to do it? Otherwise, let's add some like this, and we take this value, and then we put comma and put another value, and that's this this value, and we say this is 24. Same, there's no difference. One is direct formula, this is direct formula here, this is direct formula, and this is long cut. That's all. Parameter, you can say parameter. This is also parameter. This is formula. This is this is direct parameter. This is direct sum equal to parameter, and we can say let's say direct sum parameter, and this is all cells are added. Parameter equal to cells are added, equal to cells added. That's the difference only, nothing else. It's up to you how you do, but answer is same. So I think you get this point. Answer is same. Direct sum parameter. So we have covered in this. We have covered square. Let me put some dark here. We have covered rectangle. We have covered writing a triangle, and we have changed fonts also here. Let's change font just for what's also saying. That's what I say. So this sort of say. So we have gone to one formula, two formula, three formula. Now we can say that, like, let's say figure here also here, so that we understand what's that figure. And this is here, like triangle, and we just fill in all these sheets. So now go to complicated part of circumference and area unit. Let's say area unit are here, circle area unit, and let's say circle area unit, and this is here. Formula coefficient, of course, formula coefficient is there. It's formula coefficient, and what figure is there? Figure is there. This figure is there. We can say figure is there, and now there is only they come in two dimensions, so they can one only, and that is rather than this. We can say we have to cancel one. Let's say cancel now we may use for something else rather than this. So we here can say it is diameter. So we will cut these two values here because there's nothing to do with this. There's nothing to do. We can use for something else. Now this is what I say. This is redundant till now. Don't worry about this. But I'll just put a question mark here so that you don't confuse. We'll remove this. We'll remove this here later on. Now diameter we have. Figure is circle. Circle is figure, and formula coefficient we have. Formula coefficient is what formula of area of circle is pi d square by 4 or pi r square. You can take whatever. I am taking diameter, so it's pi d square 4. Pi d square over 4. Pi d square divided by 4. So pi formula coefficient is pi d square by 4. Pi into diameter square over 4. You can take pi r square also, doesn't matter. This is formula pi d square over 4, coefficient formula. So how to formalize that? That's the point. How to formalize that? So you can say we have pi value and we have d value. D value is here. Pi value we have to put in, and square and 4. That doesn't matter. So d value here. So what to do? A square. Let's say what's pi value? Pi value is very direct. Doesn't matter. Pi value is at, you can say You can say pi, you can say at pi. If I use, let me see, I can do that. It accepts, see, pi value is accepting. What I did pi. Oh, you can take value, just say this is pi, this is pi. Now this is pi, it's multiplied by diameter, multiplied by diameter says this is diameter, right? It's diameter multiplied by diameter, but it's not free now. Diameter pi d square over 4, so it should be diameter square. So here pi di I have taken, so I'll take, let's say in bracket, no problem. Oh sorry, it's not that. So pi d square, let's say pi d square pi d square square, and divided by 4. Let's say 4 here. I didn't take separate one, you can take separate also. So what is that? Pi d square by 4. Is this not right? It is right. 19.64. A square unit is area of this circle. Because this I have shown here, so I have valued here in this. So you can take your way. If you want to take 4 separately and then use, it's up to you. It doesn't matter. Value same. Now come on to circumference. What's that? Pi d. Pi d is circumference. Very simple. So formula coefficient I can say. Let us say cut off this here and put it in here. So I say here is L. Also that formula coefficient I can say pi d here, pi d here. So pi d is formula coefficient, pi into d, pi into d. That's formula coefficient, pi into d. Let apply this value. So again I say what's pi? I put formula my way, 8 and into pi, and this I put this formula. So it's same. Circumference we have to find, so we have got pi already multiplied by d, so we go there, multiply by d, and d is here. So what we got? We got 15 points. This is all. Now because this value has no use, so we delete this value for time being. No need. So this is what circle is. So what circle is about. So you got circumference I write full, so that you may not confuse. Some people confuse also circumference, so I put circumference as well. This is area square unit, circumference is unit, meters unit or feet unit. This is your figure is circle, so I say figure is circle. There are many others we'll see later on, like ellipse or like polygons or something. I don't take them now because you'll confuse for nothing. I don't want to confuse you. So do you know what we have done this? It's complete. It's very. I'm not saying it's very difficult, but for starters, it's difficult. Means you have to. You are formalizing something that you haven't done so far, and you may see that you have formalized something, or I should delete this as well. No need of this. So I would say it should look nice. So I'm taking it in a systematic way. So this is your tabulator formula. So here you have taken this, and on other sheet we have taken this very long formula. Well, I think by now you must be very tired. Certainly, because it's already more than 2 hours, 2/4 hours, a quarter. And maybe of course it's mathematics, and people will not like what you're liking, or you doesn't you're not liking. That's not in your hands. And if you want to really learn calculations, it is the best way, because some people don't have efficiency in calculations, and really they can manage their world of calculations by this. You can yourself see how much we have done just in 2 hours. We have researched on this and we have found this. There's so many, and I've done many applications on this. For example, I like to show you some more file if you have no problem with that. I like to show some file. I think days I have showed you, and I like to show something like this. Let me see if it opens or no. I put passport in that, so no problem. So you see this file open. So this is very, very complicated formula. This is structural engineering formula, but I'm just referring to you how it works, How it works, you can say it moves like this. This is a design here, you can say. This is a frame. I'll just squeeze it and show you what frame it is. Let's say this is a frame like means all this is slab. Slab means roof. Roof slab. This is slab. Beam slab. This is columns here, columns, and columns. Then there's another slab here, and there's column, and foundation. This is something extraordinary, you can say. I'm showing to you from different level. And this is not one. You go down. I've written the brief of this, and you'll find another one here. One story added in that, and you can say there's another one here. One story is further added in that, like that. Another story is added in that. That's all calculations on same cells, very, very complicated calculations. And then again go further, and you'll find that all other added on that, And if you go to further on that, further areas, you'll find that further added on that. Means every this application, I'm adding one more story and calculating values of moments, shear force, deflections, and many other requirements which may not be. This is 8 stories, so you can say, if top slab 8, 7th, 6th, 5, 6th, 5, 4, 3, 2, 1, and then foundations. And now if I go the other way, you can say this is different links to this formula. All these calculations are done in similar way as I explained to you elementarily. All these are cells connected together. Thousands and thousands of cells are connected together, and it's not joke. It's of course takes a lot of time, and all the formula. You can see these are all formula, not joke. All are formula. You can see here, complete formula with nothing, no cell without formula, and these all same details as I tried to give it to you. Really astonishing. Maybe it could, but it's science. It's engineering. It's the in-depth knowledge. Means you have to do, if you want to do something, to save your time and to achieve accuracy of that. Means it's not I'll just blow it up and show you, means so that it'll be clear to you what I am saying. You see, again I'm showing you this just for a little clarification. What are these? All these are cells, all these are very minute cells. You can see, you can check any cell. Whatever cell you check, you'll find complete formula like research. Complete research means you can say you're calculating something imaginary, but it is reality, because based on this, and then I have written brief method also here, how I'm doing this, how it should be done, how you use this. Means it's complete backdoor work, and it's really and if you go further, I have not only ended here, I go on further. You see this one, this further expansion of those formulas, and this is a result here. This is a result that this is a result here. It's all formula, all these results which say here this is force, at this point this is force, at this point this is force, as we do in our applied engineering and applied sciences and theory of structure, and this is what it is giving all about. And also then further calculations on that. Means everything is linked to each other, and that's beauty of Lotus or Microsoft Excel. And then this is what and then also I gone through various links of files, and I think I have links are that's point to edit links. These are links. You see, these files are linked to these files. That's the important point. These are linked to these files. Maybe I'm not able to open them. Maybe, for example, I open, if I check status, I open, maybe it's hung actually. You see, a linked file has come. You see, that's why I'm saying another link file from which I'm trying to pass loads onto that file. Means this is different file. Means everything is different here. Everything's connected to each other, and that's where the importance lies in. If you understand this point, you can understand what I'm trying to say. I'll just close this file because unnecessarily burning no meaning. So I've just tried to show you edit links files are there, and there are so many edit link files, not one, not two. Let's say another file I open, and it says this is file open. Say this is a beam file, AOBO beam. This is a beam, This is a calculation for some beam, and it's complete technical details and like that. And there's so many sheets of this, not one. You can see different beam here, different beam here, different beam here, different beam here, different here, and there are so many on this. So there is some because of this. So what I'm trying to say is I close this file. Now all these values I can blow up and see this one. No problem for that. So I'll close this file as well because this is also stopping me. Do you want to say no? I don't want to see changes. Now I'll show another link file here. Short columns. Let's say this is a short column. And open this source, and maybe this is short column. RCC limit state method, and this is details of that method. I am still working on this according to my understanding. It's not if I long back. Same, I'll put this also off because it cannot access only files, so I'll put this off called no. So what I'm trying to say, that means all what basically elementarily I told you, I have already used it in my research work. Research means work or research work. You can say whatever you can say. It doesn't make a difference. I'll go back to number data and close that file because this is also same number data. I'll just reduce the crawling of these files here, and now I'll go back to that one which I started with, and I understand basically also basically here which I showed down here. Basically it's also very important to understand. So well, I think you may appreciate or may not appreciate that that's not point here. Point here is what efficiency you can achieve in calculations. Because if calculations are achieved, you can achieve designs, and if designs are achieved, you can achieve something very very important. That's all purpose behind this, and I think. What else I should show you? I don't know what I have to show you really. Well, no problem. I don't want to waste your time. I have to just try to use some mensuration, because if you know how to calculate square, rectangle, a triangle, circle, and we may have now more figures in future. May see volumes, how to find volumes. It's very easy. It's not difficult. Let's say, for example, this is square. Or it can be cube also. Means you can just expand this. Means side you have square, unity you have, parameter you have. This for square. But if you say no, I want cube. So cube means same square. Is one square, then there should be volume and surface area of a square, which is a cube. Means there are 4 plus 2 6 surfaces, and 6 surfaces, and cube is multiplication is same dimension multiply 3 times. So let's say cube volume. Let's say cube volume. What cube volume? What is cube volume? That is, what is the dimension? Is that to power 3? Right? Let's say dimension to power 3. What's dimension? Dimension is 4. Oh, sorry, sides 4. I'm sorry, I made a mistake. This is cube volume. Is dimension is square cube 8, so length breadth 8, say 8 is there, so I should take that. I'm making mistake, sorry then. Cube volume is this, so I take this 8, and as usual, you know, power 3, right, because it's cube, so power 3. What do you get? 512. So you get 512. What's that? Let's say, yeah, 512. No, I think some error here. Yeah, 8 into 8 into 8. If you take, let us say, plus 8 into 8 into 8, you get how much? 512. So it's okay. So I missed this, you know. Cube volume is there, right? You got cube volume, you got cube area. So you can find cube surface area also. That is square. How many square? 6 surfaces are there. 2 top, 2 sides into there. So 6, 4 and 2, 6. So you have one surface area with you. That is square area 64 into, you multiply by 6. You'll get that cube volume and cube surface. Cube surface. Remember, I'm talking cube, I'm not talking solid. Cube surface. Surface is a box I'm talking actually. You can say it's a box, you know. Cube surface. So we have already square unit area. So there can be 6 in that. So you can say this area multiplied by 6. You get the answer. That's what is required actually. You got this answer here. Like this rectangle also you can do same formula, and you can use it in whatever formula. Understand? Well, I'll try to give you something else also as a, for example, or I should say, you know, tables using how tables work. Let's think of tables, you know. Tables, how tables work. Pahade. A difficult situation for students, you know. Let's say 2, let's say 3, right? So let's first do like this, you know. Then I'll put like this, you know, plus let's put like that 3, you know, plus 2 plus 1 is 3. Then let's say let's up to 25, 18, 23, 24, 25. And just take up to 25. You won't take up to any number. Doesn't matter. Now, I want to say how to find, how to you know, they say 2 into 1 is 2, 2 into 2 is 2, 3 into 1 is 3, 26. So how to calculate that? Point is that let's say 1. I'm saying 1 here, sorry, 1 here, and then I'll put this in same way, 1 plus, and then I'll say, you know, 1 plus 1 plus 1, 2, and I'll pull down. Let's up to 10, this up to 10, okay, let's up to 15 or 20, no problem, 18, 19, 20, let's find 20, and this is, you can say, table number, and I will see table 2, table 3, so I will take, you know, we'll just adjust it so that it's convenient for everyone, it's convenient to all. So we take like this. No, what I do now, what we should do, question is that I say I want automatic of this, 2 into 1 is 2, so it's very easy, means it's very easy. 2 into 1 is 2, right? So we say, well, this center is the point here, you know, I'm taking center here. So the oh my god, center should not disturb actually. So easy for you. Let's reduce this. Yeah, I'll reduce this. So what I do, I'll try to centralize this. Okay. Formatting is you know, Now 2 into 2, and let us say if I just take it down, something wrong here. Wait, sorry, 2 into 2. Then here it is 2 into 3. 2 into 2 into 2, 4. All right. 2 into 2. What we did? 2 into 1, 2. 2 into 2, 2, 4. So if you take it here, something here, plus 2 into 2 into 3. We have to just little work on this. 6, then we can say 2 into 2 into 4, 8. Then we can say here 2 into 5, 2 into 5, 2 into 5, 2 into 5, 10, like this. You can go up to whole. And also because we cannot take values all time from here. So what we do, we put another insert here. We put another insert here. We put another insert here. And you see, why not to copy it there? Copy it there and put it here. Right? Then you again copy here and put it there. For other one, put copy here and put it there. Other one. Then like this, I'm just explaining. I will copy later. I'm just trying to say how to handle this. So this 20 also has gone. So let's say 20. We can just pull it here because it's formalized. It's also formalized, so automatically it comes in. So now what to do? As we said, let's say now we say 2. Once you do only 2 into 6, that's 12. 6. Then you can say 2 into 7, that's 14, right? And then we can say 2 into 8, that's 16. And we can say, I'm showing very nominal way, very elementary way. 2 into 9 is 18, and we can say 2 into 10 is 20, and like that, 2 into 11 is 2 into 11 is 22, and then we can say 2 into 12 is 24. We can say 2 into 13 is 26. Then we can say 2 into 14 is 28. And we can say plus 2 into 15 is plus, then 2 into 16 is 32. Then you can say plus 2 into 17 is 34, plus 2 into 18 is, like I say, 36, plus 2 into, there's another way also, but I'm showing very elementary way. I'm not showing you in dollar way. There's a dollar way as well. So you should just understand basics, and that's very important, because once you understand basics, you can decide anything. So this is table of 2, 2, 1, 2, 2, 2, like this. These are controls, all these are controls. You can see these are controls. I put them as controls. Let me put them a little wider, sorry. So you can see these are controls. I put controls in, and let me first of all do it times and my unit I'm using, so it doesn't matter to you. And also I take this a little wider in a sense that font should be, let's say, 12 or 11 or something like that, or 12 it should be. So I'll click clear now. No, because we have formulated this. This is our control sequence. It's also control. You can say kind of serial number. You may say serial number rather than that. Okay. Now, just for your understanding, I'm telling that. So we have used this one 3. We have used that. Okay. Now what I do, because this result is of 2, I don't care. I copy it and post here, post here, and that's it. I'm sorry, something wrong. This is 2 1. So wait a minute. This is a result here, 2 into 1, 2 into 2. So this value is B3 into A4. B3 into A4. I see. So some error was there, so no problem. Error was there. It happens sometimes. Now we have to take, for example, we take this one here. What answer you're getting? 3, right? What answer you're getting here? 3. If I take here this answer, you are getting here this answer, right? 6. This means this cell is linked to B3. So what we do, if I take this here, it should come here like that, right? 9. So if I take, or let's say so many cells here, it should also come here similarly, right? So if I take this cell here, it should come like that, right? So it's giving 3 into 20, 60. It's giving correct formula. Now how to handle it further? That's the point. Because we copied this to this. If I say I copy this here, I must get answer. So let me see, I copy here all this. I must get answer here. And here. So what to do then? Let's insert now everything somewhere else. Let's insert now here, everywhere. Insert. Alright. Let's say it is up to 10. Now let me say now first of all, don't confuse yourself. Just copy like this. Let us finish this as well because I think some error is there. No problem, it can be corrected. It doesn't matter. You can say 6. So it can be like this, 80. So it doesn't matter. So why say I take it here, for example, it's also not complete. So this is here. Now I take whole as this one, and let's try it copy here. Right? What has been? We are going 6. Now we see 7. We see 8. We have seen 9. We have seen 10. We have seen 11. So if you go further, up to 10 only we did. Others are mistaken. So we have gone up to 10. We got it. So 10, 20, 30, 40, 60, all 100. We got 200. Now let's go further. Because we are doing up to here. So what I do, I again insert here. I insert. So let us say insert all the way. Insert up to all. Because we are going to insert that. No, that's internally we have to insert. So this we cannot take directly. So we say insert here. Insert here. So like this we have to insert, and we have to insert here, and let's say we have to insert here. Let's say it works or not. So it's not working. So we have to insert 14. We have to insert 13. Yes. So 11, 12, 13, 14, 15, 16. Let us see 17, 18. Like that we insert 17. We insert 18, we insert 19, we insert 20, and we insert, let us say 21, we insert 22, we insert 23, we insert 24. So we have inserted 25 as well also. We inserted this. Now how to save time? That's only question here. How to save time? Now let's say all similar pattern is here. So we can say let's say here, let's say you can see 11, you can see 12, you can see 13, you can see 14, you can see 15, can see 16, you can see 17, you can see 18, you can see 19, you can see 20, you can see 21, you can see 22, you can see 23, you can see 24, you can see 25. So you have completed tabulation up to 5. I'm sorry, up to 25. Tabulation. This is counting tabulation, you can say. Counting tabulation. Counting tabulation. Formula application, you can say. Application. Counting table application. Your kids will be very happy if they know you can just do it that way, but that's not good way. You should remember, but it's only for research purpose. I'm just trying to tell you, and it's not that you just stop here. Don't stop here. Don't stop here. Just try to manipulate it, like let's say one by one, rather than running away like this. For example, you can say it can further expand, it can further expand like this. So let's say it's expanded to 30 already. So let us say, why not expand this? Let us say we expand up to say by chance, say we expand say up to here. So let us expand it, you can expand gradually as you understand, as you know. You can expand gradually. It doesn't matter that you expand. You can expand here, and well, I think there's some error. I should hold it on. There's some error is coming. I should hold it on. 726. No, there is some error. Let me be little patient before doing that, because sometimes formula is applied wrongly, so results are wrong. That's also an important point. You cannot simply say everything is fine. So I think I should stop here, because this is something wrong. I don't want to accept wrong. So I will check later on how to adjust this. So here I delete it. Well, it's all on spot working. I'm giving you. So you can do like this, and you can expand. If you let's say what I'm saying is, let's say I take it from 21 to 25, right? Let us try how it works. Let us try. I'm not claiming anything. Let's start working. That's a 20 cent. Already it is 30, and if you go further down, then you can say it's 35. You can go further down. You can say adds 40 and adds 45, and 9. If you go down here 50, and then you can say 55, and then you can say you are counting your table up to 60, 65, 67, 70, and then 80 and 75, and then 80. So you can say you can do that up to 85, and then 890, and then you can say 95 and 100. So you see, you have reached up to 100, and there is no limit at all. Beauty is that there is no limit. You can say you can reach up to 101 to 110. You got my point. So you further do it, and you say, oh no, I'm not happy with that. So you reach up to 120, and then 130, and then 140. You see, you're calculating, you're flying, you don't know. Your rocket, you're firing a rocket, or your mind is an atom bomb. You don't understand. but you're getting results. That's beauty of this, you know. You're getting results. This is formalized. This is application. So you're getting, you know, you're getting all this. You see, 180, and then, you know, 180, and you see 190 and 200. So how many minutes did you take to reach to 200? Just a couple of minutes. Really, it is surprising calculation. If you take it now, I'll do something else. I'll take it from 150 onwards, and I'll show you how does it work again. I'll take 150 onwards, and let it go, and I'll hold it at 200 right there, and I put a copy again, and you see, well, I think, yeah, I'll put it here and see how results comes in. So I'm sorry, it's an error. It disappeared. Actually, I have to do again, because this command, I lost command. Command should not be lost. So that's the main point here. If you lose command, you lose everything, you know. So actually, I lost command there. No problem. I'll do it again. No problem. This is research. So you can say now you have reached up to 250, and still I try if a command is there or not. Let me try. If I have command still in my hands, I am not sure. Still it's in my hand. So so you can say you have gone to, you can gone to, you know, 289 to 90. You're going to 300. I think Axel will not accept that. I'm sure. Let's say let's say it is 324, and it's going to 350, and let's say it's going to how much now? It's going to now, you can say, your kids now will get mad, and you shall get mad as well, because nobody can remember their formula. And so this is now, you know, I think that's maybe end of sheet itself. I'm not sure. Let's see. So it's gone to 500. So here in your hand is a formula. You have in your hand this table of 500, and you must be surprised in how fast it is, and that was game of computer is. People don't understand what worksheet is, and that was my reason only to handle with you, to just educate you, just to disseminate you how this works. And I think it's 600. And I was just enjoying. I think you're also enjoying, so no problem if you take some time. And it's like entertainment, you can say. You can entertain your brain, just sharpen your brain, and you can sharpen your brain, so your brain can be sharpened like this. This is a good game rather than playing unusual games or bad games. This is an intellectual game, and you can say. So it is now 700, 800, 700 to 800 now. So this will be 800 now. It's now 800. A counting of 800 table, and it's very wonderful if you could do it. And this is called automatic mathematics, can say. I think in classes we got to be, so we 850 to 90, I mean to say 900, and 900 to 9, so we'll reach up to 1000. No, don't worry, we'll reach up to 1000. I have some phone, I think. Let me go talk to someone. हाँ हाँ बोल. हाँ हाँ बोल. अच्छा अच्छा ठीक है, बोल देता हूँ इसको. क्या हो गया उसको? हाँ चल ठीक है ठीक है ठीक है, कोई बात नहीं. ओके ओके ओके. मुन्ने, वो कह रही है उसकी लड़की की तबीयत ठीक नहीं है। प्रोमिला कह रही है उसकी लड़की की तबीयत ठीक नहीं है।
अच्छा।
उल्टियाँ आ रही हैं उसको।
बेटी आ रही है।
हाँ तो वो बंद नहीं हो रही उल्टियाँ।
हैं?
उल्टियाँ बंद नहीं हो रही हैं उसकी।
अच्छा अच्छा अच्छा।
वो नहीं आएगी कह रही है।
चल कोई बात नहीं।
बता रहा हूँ। So, so you see, I'm sorry. We reached up to counting of 1,000. So really, this is something, maybe some people will go back to control home, and we'll see how can we manage. So you can yourself see, means you can, I'll now browse again how counting of 1,000 have been done. That's very very it's very point that is here. You can see yourself how this counting is done. How could it happen? Let me see whether this video is working or no. Yes, still it's working. So I'll take a couple of minutes here so that I can finish this. Here you can see all it's how fast it's moving and how fast it's working, and that's really an interesting point. You can say up to 1,000, so I'll move fast or not fast. That's another point, but it's working. That's so I won't waste time. I'll just move on to from 500. I will take. Let us try if I can. I'll take from 500, and because I can't take a whole together, so I say I take from here. Alright, I take from 501. From here I take and we move down to let us see how it can. It will take time, I think. We have to be very careful about this. Means that's the problem. Means you have a chance to break your command, and if command is breaking, means everything goes. That's only point. So so we have reached up to 1,500, and then you see we have reached to 2,000 now. You have to reach to 2,000, and this I'm just trying to show you how this formula can be done. So you have seen 2,500, and then 3,000, 3,000, 3,000, and then you can see 3,500, 3,500, and then you can see this is what is magic in this. This we call it mathematical magic. 4,000, and now I'll say that you can say that it is 4,500, and this magic you have to understand what magic it is. And this is 4,500, and now 5,000, 5,000. You can imagine 5,000. You can say 5,500, and you can say this. You can't imagine that, and then you can say 6,000. I go to counting of 6,000, and here it is. Here it is. You can say that 6,500, and this is, you can say again 6,000, 7,000. So you're counting it with 7,000 now. It's gone to 7,500, and then It's gone to 7,500 now. 8,000. 8,000 is gone to, and enjoy, enjoy, enjoy. Take a cup of tea and enjoy. Now, information cannot be pasted because copy area and paste area are not same size and shape. Try one of all. Okay, leave it now. This means there is no space and sheet left. So we have used sheet of this program. So anyway, we have done up to 8,000. I think that's good enough. So congratulations to those who never did this, that this is what Excel can do for you. Got it? This is what Excel can do for you, Lotus can do for you. What I'm going to say, sometimes you find people, sometimes, so your counting table is this, and then if you what I say, what can I say, if you just copy this as it is, what I'm trying to tell you, you understand? If you just copy this as it is, like this, just copy this as it is like this, and put in next cell here. Next cell, that's very important point I'm telling you. Put in 25 or 20, it doesn't matter. Paste it like that, we'll find something else here. We got a repetition of that, right? Now you have to go to, well, I think better is if I give a gap in this, it will work better. So if you go to 8,000, if you go to 8,000 cell, which will take time, so sometimes we have to, as that control and, let me see if I can do by control and. Yes, I can do by control and. So what I'm saying is, here again 8,000. You see here it's the same copy. But what I have to do, I have to change 8,000 here. It is in cell number W. This is WQH. Cell is WQG. This is WQH. WQH3. So I'll go back. WQH3. Yes, WQH3. So I'll go back. WQH3 plus WQH3. So what I got? I don't understand. I got that value of cell 8,000 here. Correct. That 1,000 here. Right? And if I add to that 1, let me try. I add 1. So if it is added 1, it becomes 8,001. So continuation to that one, it's 8,001 table. And 8,001 table, and if go back to end, you'll find 15,999, right? 15,999. So 8,000, it was 8,001, that was 15,099, right? And if you just give 1, just to make it 16, let me say, let's say this is, this is 25, WQH 25. Let's start with that. Then again, I'll go back home, and WQH it is. So let us see how it works. WQH it is. So what I have to do, WQH, let us see. Let's copy this and put again there. I mean to say here, and I say 16,000 now, as it is there, 16,000. So I would say 60,001. It's automatic now, because 15,001. Let's go to control end. You see, it's already 23,998, and 6,001 is there. So we'll take 2 here, and like this, you can take any number of extensions. Control home, right? Control home. So 8001, then 16,601. So you can also say 15,099 is there. So we can say WQH, and that should be 25. WQH 25. So we will remove this, get this here. So we will get 15,999, right? Depends. So then you take another one on this, and try copy, and you get this one. So you are getting what? Understand it, you are getting breakthrough now. You are getting 31,995. It depends upon what is the adjustment is. So this is counting table applications. I think not practical maybe, but calculation wise it is, and it's not necessary that you depend on this. You can apply coefficients into this. There's a way for that. For example, 2 into 1 is to 2. You can say 2 is 1.25 into that. That's when you can do. There's no problem. In beginning itself you can do. Not at this stage. A whole table can be revised further, because we copied all. So you have to copy it again. If you want to provide 1.25 or 1.5 or 1.355 like this, not exactly 1, 2, 3, 4, 5, 1.1, then 1.25 or 1.5 like that, you can find that very easily. There is no problem as well. And because we copy here, you can say C4 plus 1, C4 plus 1 we say it's there. Similarly, it's vertically copied, it's not horizontally copied, but you can move like that. This is only basic. I will explain to you later also how we can do that, because that becomes very lengthy otherwise. So you can take further as well if you wish. There's no harm, hard and fast rule on that. And this is 31,995. So you can take further if the sheet allows, because sheet's not allowing that, then you can say automatically it's coming in. You see, automatism is this automatism, and you can say that all, and this so it's coming. You take that one, you'll find 47,991. That's what beauty lies in. And you say that this is spaced here, and you can say it's going to 55,000. That is what is power of calculation is. And then you can say, oh, automatically it's getting done. Once it's formalized, you need not work on that. 71,000, and then the table is this. That's that's automatically getting in, and you're getting that. Getting that one here. Automatically getting in 87,981, and then you can get you can see how revision it is 95,001. It's already crossed. It's already crossed 100,000. Don't worry. So it's that one. So it's already crossed 1,000. So you see how fast you can be. You apply intellectualism on this, and you see 109.75. So you can say well, I will not go further because it won't take, I'm sure. It's not that powerful, though I have only on 355 so you can say let's try. So you see bombardment, here it is, bombardment, right? But this is all scientific values, because a common man cannot understand them, but yet it's formula, and you must understand that. So you can visualize yourself where you're gone through. It's increasing in every 1,000. In every value it's increasing in 1,000. So already 153. So you can say in how many minutes here is the in how many minutes you have covered that 159. You are covered, and you are covered. Already you have gone to 159, and you are covering so fast, like bullet train is also slow, I think. I think 167, and soon we'll reach 200,000 very soon. You can see this what is called mathematical mind, analytical mind, you can say, rather than mathematical mind. You can say it's analytical mind, where already I think it's gone to 100,000. Already it's gone to 100,000. So I think the sheet won't accept anything else. So let's 199. So let's say I want to see figure 200,000. It's already done, but I'm just trying to show you where's that. So my dear friends, this is what 200 solves is, and this is where I want to say, it's where it is easy, it's here, what I can say. I will put this in some savings so that we can later on put this back on ourselves, so that I can't bring it back from I'll put this formula 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 I put back here, formula. So that's it. Now what I'm saying is that saving may not be easy. I'm not sure. I don't know. Anyway, it has taken. No, not taken yet. I'm not taken that yet. It's still working. It's working. Well, let it do its job, and we are here. Already 3 hours passed on this calculation method, which is really extraordinary. It's extraordinary for the people. So name of this file is formula I've given, and I'll try to take it back if I can. I'm not sure I'll ever take back such a big file, and still it's not giving clearance, whether saved or not saved, and yet doesn't matter. It's working. Let it buy. Well, I think it's powerful, yet it is saved. So where we're gone? We are going to, let's see, we're going to where? We are going to end, and that is 215949, and then come back to home, and that's what. So my dear friends, what did you learn from this? I think maybe today you can't sleep, right? You can see that. This much I can just in 3 hours. I'm not sure how many minutes have you absorbed successfully. That's up to you. But you must have absorbed. You can download. You can use this video for your for your work, and you can, if you are interested. That's I can't force someone, and I'm closing this file. I just kept it for your memory. So I am closing this file. So I have 2 files here. Now I have only this file here, that is sheet 1. This is here, which I'll close again. What we learned actually really mentally, but in a lengthy way, and this was what we it's very very long actually. We have gone so long in this. You can see that one, and I'll keep off because I come now. I not captured to speak more than 3 hours yet. I can't continue for 4 hours or 5 hours as I used to be. I'll do it later on when I come back from this problem, and this is where I started. I'll just play with again with this because it's change of formula, and that's very important, you see. And I say 100 value we started with, so let's say this value is minus. Let's say this value is minus 500, and let us see results change so quickly. You see it, so no value is not accepting. We come back, we'll put positive values there, and it's afraid actually. Let's say 3 to 2,500, and 2,500 is accepted, I think. Let's go back to 100 and see it's changed. You can see there's change every time. You see there's a change immediately, and you see it takes time, some processing time, but you will come back and you see various changes, all completely changes. That's the important file. That's the important one. I think you people You may be getting what I'm saying. It's not simple. What I say is right. I can sing, but that's really some broad view I have given to you about calculations that can be applied in engineering or in science or in insulation or in some general calculations by everyone. Maybe you may not get grasp of this full, but because of my experience, I explain to you. I'll keep explaining to you again and again, and you may try yourself, and that's very important point. And if you don't try, say without trying, nothing is possible in this world. If you don't try, you can't do anything. If you try, you can see. We have just seen how many tables we have done. That's point. That's point is very important point. And let's see, these are all linked. Now, let's say I don't want to. I want 0.5. Let's say this I want 0.5. You understand what happens? Say you got 0.5. Believe it or not, you got it. You getting it? You got it. Let me do it again. Let's say no. I want a table starting from point 1. I want to start from point 1.5. Let's point 1.5. I'll put 0.15 in that. You can see 1.0.5, then 1.15, then 2.15, then 3.15, then 4.15. Can you believe it? Can you believe it? Do it again. That's a no. I don't want to start with. I want to start with something, minus 10. Let us say minus 10. Minus 10. I put it in here. What do you get? Minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, 3, minus 2, minus 0, 0, 1, 2, 3 again. Can you believe it? This is called application. Automatic it works now. Nobody can stop it. My God, what are you doing? Yes, you have to raise a question. What do you want? What do you want? Let's say I put it 2 to power 0.23. Let's say 2 is there. I put a power here. In this case, I put a power and say I want 0.3. What's value? It's not giving a value. No, it's giving value, but it's not able to show. That's the only problem. So I've come back because it's not showing. Now it's showing because that was not in cell capacity. Our rows, our columns are not able to show that. That's the only problem. Now let us say I use 2 to power 1.5. Let's say 2 to power 1.5. Let's say 2 to power 1.5. Sorry, it's something wrong. 2 to power 1.5. Again, same thing happening, but value is there. Remember, it's not showing, but value is there. Value. Let us come back now. Now, 2 to, lakhs and lakhs you have. Let's see, go back, control, and you see how many values. It's changed everything into E value because its cells width is not accepting that. It depends on. So now we go back home. You know what we have done in just in half an hour. Can you assimilate what you have done in half an hour, and what we have done in last 3 hours? Can you understand this? It's very, very, very important point. In last 3 hours, we have changed whole mathematics. Well, we have moved it in such a manner you can't even blame. That's what we have done. And that's what's required. It's required. If you can understand all this, I think you can make something extraordinary. You think I worked for years in streamlining this formula. Just in 3 hours, I have given my years of experience, some experience you can say, not engineering experience or something, but It's for everyone. It's for everyone throughout the world, not only in Bharat, India, it's throughout world. Every world citizen can benefit of this. You won't find this in Excel box. You won't find this somewhere because this has nothing to do with this. I'm not using any formal formula given on this worksheet. I'm using my own mind. You can use your own mind. I'm not interested in decoration. I am studying. I was interested in controls, controls and controls. If you can manage controls, you can manage everything. That's important point. Important point. That's very important point. I've shown to you. I've shown to you. You know, I've shown to you. You can say. Uh, I've shown to you a kind of multiplicity of files. You can say Excel files only because when I share screen, there's a restriction. Practically, I've seen I cannot bring another format here. If I want to bring to you now MS Word, I have to close all these Excel files and do another video. Probably, I'm not sure. I'm experienced that. If I want to use PDF, I have to use PDF only. I can use so many number of files of PDF. But if I have to use Excel, I can bring only Excel files to your projection. That's what I am experiencing and understanding how Excel or Lotus people have designed. Means they have not given you broad view. You can't change documents format. Same document you can use. I have worked on Excel sheet. I have worked on AutoCAD sheets. I have worked on MS Word during live class and it's working. And that's only achievement you can say. That's only you can say a kind of efficiency you can get from this. This is a very very simple to see how many rows I copied. You can see in this. This is number one. This is number two. Number one is you can say 2 to 8,000. Number two is 8,001 to 50. You can say around 16,000. Then you can say about 23 9 times up to 23 9 and 7. And then you can say 31,955. It is 39,993. Then 47,991. Then 55,989. Then 63987. Then 71985. Then 79983. Then 87,900 something. Then 95,000 something. Then more than 100,000. And then more than again 100,000 up to 05 and then 05 and 05. Like that, this is going on increasing and increasing and increasing. And at end you can say you are more than 200,000 counting of tables. Pahada we call it in our language, in our Hindi, Pahade. So you can understand what's happening here. That's point here. Now by chance if I say no, I don't want to hear, I want to not add one. I want to say here I want to use this one and I want to enter 0.25 here. 0.25. What shall we value? 0.25, 1.25, 2.25, 3.2. Like that you can change everything. Everything is changed in this only, not in other word, because I have copied that one. I've not linked that one to this one. So this doesn't work. Only here there is change, which I don't accept because that's not formula. That's just chance. So I remove this. I said no, I want complete change, and that change I'll display to you next time because it's too much today. I just try to explain to you. If you want to use this, I gave you certain clause, and that is this clause. You have something like this, and then you have to something like this. That is table. This is this one, and here I have seen. I think I put some mathematics here. Where's that? Yeah, it's that. It's that. This is very important. I put in blue. I'm sorry. In I can say I can put this in color if it's possible. Let us see. No, this is not correct color. So I'll put in depth color. So this which is best. So this is important point for you. I'll just if I put this also in color because this deserves this, and so You can say, though I don't need this color, I need this color automatic. So here, this is what I say. You can, you can, you can understand these basics. If you can understand these basics, you can understand a lot. You can change your mathematics, arithmetics, mensuration, engineering mathematics to some extent. I'm not going through complete engineering. I cannot claim that it contains engineering mathematics, but quantification can be done by this. Yeah, I was trying to show you trigonometrical files. I don't exactly remember, but I sorted that out, and also time is now permitting that today because. Everything cannot be explained to you, and I don't want to confuse you people, so I'll just I don't want to use undue information to you. So I think I should now what I should say, what I have taken today. I'm sorry, I don't exactly remember what I've talked to you from beginning of today. I thought something. It's already nearly 3.5 hours, and I think it's better if you use this time for amending your knowledge of mathematics. I'm not saying you will be able to use calculator like this. No way to use calculator. I'm just using Excel and Lotus 1, 2, 3 in combination, and which is very important part of what you can say, very important part of you can say very engineering very useful part in calculations. And if you want to empower your calculations, to empower your speed of calculations, you have to understand each value of cell, and that's not difficult. And if your sheet permits power copy and paste, you can copy and paste. That's very easy one, very easy one, I can say. Copy and paste, you cannot say, means if you copy just what I say, if you take, say for example, you write some value in whatever cell, and then you add some value to that one for another cell, that's called formula, origin formula, start formula. Then you can try copy that formula from that range to from there to many other ranges, and you can get direct answer rather than pulling that. That's possible, but I think by chance my file is not allowing that. I don't know reason. Maybe it's old one, or I forgot that formula. Let's copy this formula and paste somewhere else. I think I either forgot that formula, or I'm not, my sheet's not permitting that one. That's anyway different case. But as far as calculations are concerned, as far as copy paste is concerned, or pull handle is concerned, or as far as your shortcut formula, or your in-depth formula, long range formula, whatever you want to use, you can use. You can save your time. I just given you rectangle, triangle, and square, and circle. These are very elementary figures. You have to find space calculation. Space means volumetric calculations. You have to find irregular calculations. Whatever formula you have, you can use that on Lotus 1, 2, 3 or on Excel. I prefer Lotus if I have Lotus, but because this is it's not that valuable. Well, but we are using, I'm not interested in formatting. I'm not interested in coloring. I'm not interested in anything else. I'm not in the fill or something. I'm interested in real use of formula, because real use of formula is really real. Otherwise, you can say there's nothing real if you cannot understand that. No. That's beauty. Now, as we said in sheet 2, I also put this little down so that you have a complete picture of what we studied. Also in sheet 3, though it's not possible to to squeeze this. That's not possible. How much I can squeeze? I can't squeeze as much as possible, but I have given you something very link cable. You call them links or cellular links, whatever can you call them, and you can do wonders with them for your applications. If your applications in your office, or in your work, or in education, you can verify what you did, or use calculator sum, you are can that validated. That's very important point here, and that point is very very important. If you can validate your what you did, and that point is really very surprising. And when I started this, as I told you, I was interested in writing some numbers work, but when I asked my teacher, explain to me how to do that, he could not. He could not, and he said, no. Only sum is possible. We can't use. You can't use some other formula. But I did not agree. I said it's mathematics is accept and it has to accept everything. That was my argument with him, and I tried in that laboratory, and I said, okay, see, it's accepting minus also. Then I said it's accepting multiplication also, and I said it's accepting division, and it's accepting many other values. And he tried to have interest with me, but he could not move because well, I'm not criticizing someone, but I tried my algebraic knowledge, my mathematical knowledge, sign knowledge, plus minus multiplication division, square root, under root, cube root, all that, and I applied on that, and I copy that copy paste command, range command was very good in that Lotus. I don't know where this command had disappeared from here. Then I linked many files or flooded. You can say I spent a lot time in my career, and I am happy that I utilized that time rightly, and I applied those values and did many design works and also did many calculation works, and I have demonstrated to you what way this worksheet is a very powerful tool, of course. I'm thankful to that original person who designed this Lotus 123 IBM, and how they designed, I don't know, but it was 8,000, I think 8,000 something, 8,016 rows in those days, and 255 columns, which was very very limited one. But even for me that was on. Later on they expanded and expanded. Expansion has no limit. You can expand to whatever limit you can, but question is that useful? Point is that if you expand that, I have not seen people, and I have interviewed many people regarding this, and all failed in multiplication, in algebraic sum, in division, except out of sum. They didn't know anything. So I don't think it's fault of people, and I don't think it's fault of instructor, because books whichever are written are not qualified enough, are not consistent enough to provide reader what is reader expected to know from that. And that's where failure occurs. That's where information is always incomplete, and incomplete information is no information which we understand very well. There is no meaning of incomplete information if it doesn't work. Information is information, and there is no way you can say no, we can't do that. So I'll put this so that you can read it peacefully, correctly. So I've changed that, the orientation of that title, mathematical formula computer hidden into cell. I'll little move further also better. I'll move further as well as so that it works well. So I'll put it further so that it goes into correct hands of cells. So now it's clear. So my dear people of world, students, you may be professionals, you may be budding people, you may be engineer, you may be mathematician, you may be scientist, you may be. I can't say about scientists because they know everything, but even then, students know, and also higher school, secondary, and those who are you can understand. As I'm not saying you use it in it, I can't use that, but how best you can use this. There's so many more formula, so many more for design. I'll show you later on these all. If you wish, I can show you a few more. I showed you on many beams and columns and links and all that, and there are many more. Depending on, and it's no meaning if I show to you and you cannot find them useful for your knowledge. So that's also no sense. But what's happening is that I'm pleased that at least I spent some time with you, say more than 3.5 hours, and if you even get half of it useful, I think you will be successful. I know that it's a long talk and it's impossible to digest all this, but question is not digestion. Question is of basics understanding. As I said, how to think, how you think, plus minus division, all, and also you have add, which I used it, and that clearance if you're in your mind, you can apply formula, provided you don't depend on value, you depend on formula, you depend on link. If you are able to link these cells, and there's no limit of linking, remember. No, you cannot say, oh, I can link only one cell. No, you can link whole sheet. And not only whole sheet, you can link one sheet to other sheet in any number of cells. Then you can link one sheet to 100 sheets in any number of cells. Whole workbook to other workbook you can link. There is no limit. I raised this question to Microsoft in 2000, I think 1900. Yeah, in 2000, I was finding some problem. I actually link 100, more than 110 sheets and many workbooks, and there was some problem in that. I was designing some structural formula, some formula which could be used to structural engineering. There was no answer. I said, your sheet, your workbooks are not working properly. I'm not able to link them as I showed to you link. You remember? Just I remind you with that links that I'm talking of, these data links and edit links, and in that file it was, because I have not linked anything here, so this edit link is gray. So once I links this file to some other file, certainly this edit link shall not become gray. It shall speak up, okay, oh, it will open up. I think I showed to you some file. I don't want to create confusion. For example, I'm just trying to open it again. Yes, I'll try to open it again so that I can clarify my point. It is a password, so I'm opening this password use. And this is the file, here. This file is linked to so many files, and that's what I wanted. You see, this is data and this edit links. I'm talking of this. You see, there are so many links in this. So this was this is same time linked. When I was working in 1999, 2002, and I linked many such files like that. You see how many files are linked? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 here, 14. And if you go down further, and you will find here, you see how many files? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 15, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23, like there's about 30 files are here in this case. And they were, I think, in total I linked more than 150 files, I think. And there was some problem, it's not opening properly, saying properly. I sent them, they never responded, and I think they removed this linking arrangement from there. I was upset with that. You see, here it's showing because files are linked. In home you will not find this. They changed whole format. That was beautiful format of that, and 97 it was, MS 97, and that was beautiful. In the whole you will find complete. Here you have to find, oh, where is that link? You can't find link. Oh, you have to open edit, where I edit. You miss, they have changed complete nonsense here. Why you are doing all this separately? Because I had to work hard for my formula. I don't work hard, so I had to go to every. So this is what I want to try to show, because here so many. Here if you see, here are links here. This is on same page link, and there are other links as well. Here there's a link here. Same page links are these. Maybe some of them may not open now. You can see here. I stop this. You can see here. Where it's linked is written clearly, and it was 2003 actually is written here. So as you can see here, my directory was written here, and then other directory is written here. Then like this all links are written here in this, and that's what I said, and that's what I said. Also, if you see down here, you will find same thing here. Beams, where are beams are, you can see beams are here written. This is file for beams I showed to you. This is file for columns I showed to you. For everyone, this is columns I showed to you. There's a link there, and similarly, this is the license. I didn't sell this, but they just made a link for that. Same way, it's 1, it's 2 story, it's 3 story, it's 4 story, its 5 story, its 6 story, its 7 story, its 8 story, all are linked. And that's beauty of this means you have to use this powerful tool only. Otherwise, there's no meaning in spending money. For example, this is same way, all are linked, all are linked, all are linked means like that, all are linked. Everywhere you can say has a link, and also this is link here. You are saying these are linked here. These are all linked here from different locations. These are linked here from different locations, and somewhere linked, somewhere files are linked, some are means it's very complicated. In fact, very complicated information.